where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice, a flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade,
All right, hello and welcome everyone to Aether Roundtable number 141. Tonight is our 3-year anniversary. So with that, I'm going to be covering some old presentations, kind of do some highlights here. I got about 30 minutes of clips set up, and as we go over them and play them out, we will have an open discussion about them, just kind of talk about them. And then I think there were some people that wanted to share some things that they had learned and kind of talk about that. So tonight's just going to kind of be an open discussion / playing some clips and just talking about some of the things that we learned along the way on our journey. And you guys are on the stream now on your cameras, just to, in case anyone didn't know that. All right. So anyway, go ahead and begin here. Let me screen share. Should be audio. All right, so to start us off tonight, we're going to have a classic from Toby on geomagnetism. And this presentation and argument has kind of always stuck with me, and it's always been in the back of my head. I think about it from time to time. So it was awesome to go back and clip this out and actually like revisit the context of it, because it's really underused. And this was a fantastic presentation. So this is a 10-minute clip of Toby's presentation on geomagnetism that we're going to watch here. And then we'll do a little open discussion on it. So here we go.
Inner core of the Earth, were even just around 100 degrees Celsius hotter.
Are you guys good on the audio? Audio check real quick.
Yeah, you can turn it up just a hair, but yeah, we can hear it.
Gotcha. Okay.
Would be liquid. So really want to like pause here and drill that home. And they can only say this because really they don't know how it works. And the crystal lattice orientation of the inner core is like a massive topic of debate. They don't even know the mineral, like the lattice orientation of the mineral, because to have iron be solid at that pressure and temperature, they can't compute it. And so there's some theories that say that it uses a helix structure, and there's some theories that say it actually uses a cubical structure, and that it slides around as it's in its cubical structure, and it's allowed to shift and move, but it's still solid. But yeah, it's a topic of debate. And if it were liquid, the whole thing doesn't work. So ferromagnetic minerals lose their magnetic properties, and those temperatures that we're getting into in this outer core are far hotter than the Curie point by by orders of magnitude. Now, because of the static buildup and because of the great speeds of the rotation, they assert that they are able to generate so much static charge that the Curie point is irrelevant. It's able to stay above what's essentially is the magnetic Reynolds number. So then the Reynolds value is the rate of advection, or the ratio of advection of magnetic field to the magnetic diffusion. The magnetic Reynolds number in geodynamo models plays a crucial role in understanding the magnetic field generation. It is defined as the ratio of magnetic advection to magnetic diffusion. In the context of the geodynamo convection, the magnetic Reynolds number is a key dimensionless parameter that influences the behavior of the magnetic field within the system. The magnetic Reynolds number value determines a supercriticality of the the RM value determines the supercriticality of the magnetic Reynolds number, with values above 1 indicating a supercritical regime. So that means that you're able to maintain your geodynamo. And that parameter is essential for assessing the efficiency of magnetic field generation processes within the Earth's core and is a fundamental aspect of geodynamo modeling. Understanding and analyzing the magnetic Reynolds number provides insights into the dynamics of the geodynamo system and its magnetic field generation mechanisms. So the magnetic Reynolds value. So here is how that is calculated. You have Rm is equivalent to, with the magnetic Reynolds number is equivalent to the curl operator, which is represented there by Nostra, and that's multiplied by the velocity field and the magnetic field. You take that over eta, the magnetic diffusivity, multiplied by the Laplacian operator, which is Nostra, or the square of Nostra there, and then you've got U sub 0 is the velocity scale, and eta is the characteristic length scale of the velocity field. So the magnetic Reynolds number is crucial in determining the behavior of a self-sustained dynamo, and the Reynolds number has to stay above 1. That's what indicates the rate of buildup of the magnetic field is higher than the rate of decay. That right there is the crucial point of all of this, is that the rate of buildup of the magnetic field has to be, in their theory, it has to remain higher than the rate of decay. And if the Reynolds number is less than 1, that means that the dynamo is not going to be able to sustain itself. In the context of the Earth's magnetic field, the Reynolds number, it helps in understanding how the Earth has maintained a relatively steady magnetic field over its history. I think we all get it. So the partial derivative of B in this equation, this would be the magnetic induction of the geodynamo, and it is the rate of the magnetic field with time. And then you've also got another derivative here, Nostra times U times B is the interaction of the velocity field and the magnetic field. And that allows you to deduce, or sorry, that's taken, you add to that the rate of decay of the magnetic field due to the ohmic dissipation. And now let's get into the ohmic dissipation. I'm just going to read this here. Ohmic dissipation. Ohmic dissipation represents the ratio of the magnetic field buildup to the rate of decay due to dissipation. Ohmic dissipation plays a significant role in draining the mechanical energy stored in the magnetic field, converting it into heat. Interaction between the velocity field and the magnetic field leads to the buildup and breakdown of the magnetic field, with the dissipation balancing the energy loss. A critical condition arises when the system becomes unstable due to the exponential increase in the current and retarding torque, ultimately reaching equilibrium. This dynamic interplay between the magnetic Reynolds number and the ohmic dissipation is fundamental in the context of the geodynamo theory and magnetic field generation. Typo, magnetic diffusivity. So hopefully this is kind of making sense that we have a lot of problems in the core here, in that we have something that's way too hot and has way too much pressure. And then when we actually go digging down, it ends up being even hotter and having even more pressure than we anticipated. So, of computation and computation efficiency when you start looking into this. And as far as simulating the geodynamo goes, you should know that they have not simulated it. They can't. The Earth spins too fast, straight up. And I don't have a slide for that in here, but maybe I can pull it up once we go through the presentation and show. There's a quick video we can watch to talk about that. But essentially, it's many, many orders of magnitude. It spins many, many orders of magnitude too fast for them to do a proper simulation of even one magnetic event within the geodynamo. So let's talk about
is that we cannot simulate the conditions of the Earth's core exactly. And that's because it rotates so fast. And I'm not sure there's a better way to depict this other than these non-dimensional numbers, so I'm going to stick with these for now. So on the y-axis here is the Rayleigh number, which is related to the amount of convection going on. And the x-axis here is related to the Ekman number, which is related to the inverse of the rotation rate. So faster rotation is to the left, more convection is up. The Earth lives in this blue box up here. Most of my simulations are down in near this green box. I'm pushing a little bit to the upper left as we can, but it's a little bit hopeless. One of my colleagues in the UK computed to get down to Ekman number 10 to the minus 9, so here, not even Earth conditions, using 54,000 cores in parallel to compute one magnetic diffusion time, which is not very long, you would need 35.6 years of straight, constant computation time, which is a horrible PhD project. So this is not happening. I mean, sure, 54,000 is maybe a little bit outdated. Now we can do millions, but it's an order of it's an order of magnitude effectively problem. So we have to rely on this dash dotted scaling law trajectory. We have to see if we understand the physics well enough in this part of parameter space to scale up to the Earth. That's the hope. That's the mathematical part of what we do.
Well, here's the hoping, brother.
Thanks, Morley, for sharing.
Dude, my man said, yeah, it would be a fruitless endeavor to get your PhD thesis on this, dog. Like, so go ahead and do a different one.
Yeah. So there you go. I would say that the magnetic field is probably one of the strongest evidences against the globe theory. It's probably one of the greatest evidences that we have no idea what's going on.
A double lesson
confidently guess
from Toby. Yeah, dude, we have no idea what's actually going on. That's so funny and so true. Stone, what's the word for it when you have a model but you can't even simulate it because it's not even like possible? What's that called? But you believe in it?
Oh, the old unfalsifiable, or are you just thinking ironic?
Yes, unfalsifiable. Exactly, dude.
Somewhat tangibly simulatable in a small subset of a lower order of magnitude, maybe if we fudge some numbers and make some assumptions.
Like, yeah, we're all taught, from like early academia that we're in, that the Earth's magnetic field, there's this rotating core, here's how it works, and then at the highest levels you find out that they have no idea, and there's simulations of how that could even of how what you were taught as truth might not, it's not even possible to check. Guys, they can't verify it.
But I was
And
taught
then,
that in a textbook. I was shown that as
dude,
an image with the breakdown and everything. I don't understand why that can't be true. Science told me.
I think one thing I think is really like great about the geodynamo is it shows how far they will go fabricating a narrative. It's like, oh, we can't explain any of this, so we will go down like so many rabbit holes, make so many assumptions, and present it all like it has to fit within this specific radius. So they really do have to fit it all in there, and it gets really wild really fast. When you start looking at all the like crazy assumptions they have to make, and yeah, I think like just the fact that people would assert these things and you would be taught them, like you'd be teaching these things to like a high school student is really just like is really kind of gross, like why are you talking about this as if it's meaningful in any way, shape, or form, can't be measured. It's like literally role play. But yeah.
yeah, it's a mathematical framework in which to try and fit dynamic consequences into a conceptual model, like you said, of a specific radius. And we all know where the specific radius came from interpreting how the stars change position when you traverse the land.
Dude, imagine getting a PhD in a specific lore of one video game. Like that's what a PhD in a geodynamo model would be. Like, like I'm gonna professionally maximize these set of circumstances that we can never actually confirm.
Just
Yeah.
man, the amount of compute power they're using to like try and run these numbers is crazy to think about. Like you've got literally like who knows how many people just devoting their entire, you know, professional career to trying to compute trying to compute some kind of role play. That's so wild.
One day I'm gonna get a simulation of a thing I can never test. You watch me. I'm gonna do it.
Yeah. Well, think about how crazy it is to have a career in something that has no physical meaning or application. Like
Yeah.
what?
Well, so
Like
not
what?
not
Like
only
what?
that.
Like what are they even producing? Like, because
Well,
like
so that's
when you get a PhD, you have to contribute to the field in which you're getting your PhD in. It's not just like you take a test or something. So it's like, what could you actually contribute to the geodynamo field?
Right. Like at
That's
least a
really
monk maintains the temple. Like that's
But isn't
crazy.
that
Yeah.
that's what theoretical physicists do? What are they maximizing? They contribute nothing, and that they're lorded over other celebrated fields for being experts in literal fantasy. So even worse.
Oh yeah. Well, now that you say that, it kind of makes sense about the structure. Okay. All right. Yeah, but that was a fantastic Prezi, man. Like I said, that stuck with me for all this time. I like think about that, and I just never argue it. But it's right there for the taking. There's no coherent explanation for how Earth has a magnetic field. So
I think it's
now,
like the thing we exist within, right? And so trying to measure it meaningfully, it's like trying to measure from within the thing you're trying to measure. So it's kind of crazy to try and make a bunch of assertions about it.
yeah, you can only really tell a story about what you think the causal mechanism is because all you have is the measurement of the thing that you're within. So you got this measurement, and then you're trying to backwards engineer how you think it works based off of a cosmological model that's given to you based off of, basically an internally consistent system of ratios again. And so trying to make that like a physically real model, like there's consequences to it, and they can't, they can't even test them. They just postulate them.
But
One
as we
other
found out with the model, all they need is a system of ratios, right? They don't actually, it doesn't matter what value you assign to that radius. The point is they all work together and they all will always work together no matter the value.
Yeah.
one other last note
It,
on that. Oh, sorry, go ahead.
oh, you're good. You're good. Go ahead.
One other last note on that presentation. One other thing learned while I was researching that was about how diamagnetism, which is just the lack of magnetism, like being in a magnetic free environment, actually kills things. It's uh, life reducing, and so
Oh, really?
yeah, that is in that same presentation. And I think that's really interesting when you consider it all. I kind of go back to that idea of like it's what we exist within. So like, and that includes life. Like it's like what life uh, thrives within. So I yeah, make of that what you will. But I think it could kind of play into the fabric of existence or whatever.
Yeah. Yeah, we could only speculate on the causal mechanism. You're welcome.
I
We
like
were just talking about the geodynamo model. I think you brought that up a couple of times on your streams.
I like to play
Tony
what it
did.
isn't too, you know.
Yeah, yeah, dude, their hypothesis uh about it being like a molten core that's rotating or whatever. It's like, well, we can definitely rule that out now because you can't
Yeah,
even
you know.
simulate it. Like we now know what it isn't. So thanks. You dedicated a whole field of study to what it ain't. So that's cool.
It's solid, but it's liquid. It's conveniently plasticky.
Yeah. Yeah, if anyone else has any things to say about the geodynamo model or uh, you know, the idea of making measurements of the thing you're within and then asserting the causal mechanism as if you have like an external God's eye view of the system. All right. We're gonna move on now to
Magnetic
Shane's work on coordinate systems and internally consistent ratios. So one of the big things that I started noticing in here, and especially when we're looking at stuff with physics, is a lot of things are ratios of one thing, and then you use that ratio in a formula, and sometimes the original thing that it came from gets lost, right? They kind of forget about that, and they interpret just the ratio itself as like this physically meaningful causal mechanism. To kind of give an example of that, that would be like Kepler's laws, where the ratio of the periodicity in pi gives them a physical dimension of how long something would be. Or I'm sorry, like the semi-major axis of an orbit. Not long, but you get it. It gives them a length, and then once you have a length of something, you can take the how long it takes to traverse that circuit, and you can get a velocity out of that. So you can start to relate physical values to ratios, and then from that you can combine things together and make other systems off of that. So when they get into gravity as a causal mechanism for planetary motion, well, the GM is just a ratio of Kepler's laws, which is the period in pi. So it can never produce anything incorrect. It's always going to produce the period because that's what it started with. Your input is your output, as they say in circus school. All right, here we go.
That's
on
vital.
This. Yeah. So this is I was actually making a compilation of some different videos different prezzies that you made, Shane, to show the progression. But there was this Flat Earth Friday clip, shout out to Flat Earth Fridays, where you went over the whole gambit here, and then you made a video, you went back and edited it. Made a video and edited in graphics and stuff. So we have the perfect all-in-one 11-minute video here. So here we go.
Nice.
Nation, meridian corrections, more time zones in the south and the north, like different stuff like that.
I guess
there's numerous tools you could use to hide distances, especially over water, and then the terrestrial distances though would still match because they're all derived from a terrestrial meridian, right? So miles, kilometers, and all that are all derived from the nautical mile, which is derived from a terrestrial meridian.
I get what you're saying.
It's all a ratio,
right?
It's all a ratio of the coordinate system that was derived from the stars, from angles to the stars. So it's going to work out. You're going to be able to use it and verify it.
You're saying
Nautical miles are specific, right? They're units of a circle. They're specific to, or they only ratioed them to statute miles based on the metric comparison that Alan was talking about, which is the definition of a meter, right? They used to ratio it against a terrestrial meridian, and at the conference they literally said, what the goal is. They want to reduce it to a length of a quarter of a terrestrial meridian, and then they said, it's going to be ratioed against the speed of light, except 1/299,799,458 is still the same exact metric of 39.37 inches. So like when you're measuring things in meters, it's just ratio to a terrestrial meridian. Terrestrial meridian, by the way, is the thing that is necessitated for a sphere. So
it's they use the stars to somehow like extrapolate like the Earth, I think you said.
Yep. I mean, I can do a quick rendition if you want.
Yeah, no, I just want some clarification on that, and then I got a question about it, but I just want to hear it again to make sure I didn't mishear it or misunderstand.
All right, let's see if I can get better at this. Right, so what do all worldwide maps project? Coordinate systems, not the globe. What do the coordinate systems project? They're based on a datum to tie them to the world. What are datums? Things like spherical datums, right? You have geodesic datums, WGS 84, 83, NAD 27, NAD 83. All of those are spherical datums. That's what ties all the things that are projections to the spherical graticule, which is the gridded network of longitude, latitude, right? Nothing to do with the Earth so far. Now, longitude, latitude based on the stars. In the old days, it was called cosmography because there's a very real, indistinguishable relationship between stars, lands, and maps, right? For every single point on Earth, there's an equivalent unique position in the sky. That's how right ascension declination ties to longitude, latitude. There's a direct one-for-one correlation. That's how you get ground positions and zeniths from a star. If there wasn't that one-for-one correlation, you wouldn't be able to celestially navigate. Now, distances between these two coordinate systems, and we're talking about geographic reticule, which is the coordinate system of longitude, latitude, is determined by nautical miles. Again, which we went over, a unit of a circle. Sky miles, navigator's minutes. 1 nautical mile, 1 minute of degree, 60 minutes, 1 degree, 1 degree, 60 nautical miles, right? And the power of that is that the distance determined by the nautical mile, once ratioed against the statute mile, as in the conference that we just went over, then is invariant between coordinate systems. So the distances measured in nautical remains consistent no matter the shape of the underlying topography. Again, we haven't actually calculated anything on the Earth. When we've looked at the sky, we've done trig, we've calculated a ground position for that potential star. We haven't measured the ground. We've calculated the ground based on the sky, right? So that means whenever we're using nautical miles or the equivalent statute miles, whether the shape of the Earth is a sphere or flat, we're using it based on the stars because we have a geographic reticule derived from angles from the stars and the celestial sphere itself. So we're comparing the celestial sphere to angles from the stars in a 1-for-1 spherical comparison. Anyone with me?
Yeah, no, that was excellent, man. That was really good.
And if you want to give the quick rendition on lat long, dude, this is the craziest story you'll ever hear. Like the amount of effort that was put into this. And it's like, people were like, where's your map? It's like, yeah, dude, where's our secret society unlimited funding? The ability to impose a decree where you say, hey, this is now the coordinate system. Anyone that uses a different one is fined $30 in a time when $30 is like, you know, a devastating amount of money. It's crazy, dude.
We can do the historicity of longitude if you think it'll help.
Yeah, it's always a good rundown, man. It's crazy.
Right. So we have, if you look at Wikipedia, longitude was invented, say, 200 BC by a dude named Hipparchus, who also invented a variant of a sextant, a distance to the stars, a variant of a sextant. He was taking apart a form of geometry. He's accredited with a whole bunch of stuff, but fast forward to like 1712, and the Board of Longitude came about from the Royal Society, and they decreed, electing themselves the Board of Longitude, they would, find the furthest southern extremities of longitude, and they needed a device called the chronometer, right? And this is a prompt from Isaac Newton, who was like, no one can create the timepiece that would maintain this at sea to be able to get the furthest reaches of one. And then some craftsman dude who'd never made a clock before in his life came out and met Isaac Newton's challenge in the public and created the best chronometer that anyone's ever seen. And now they'd be able to tell longitude. And then they were sent on a mission by the Board of Longitude based on a decree in the Almanac of 17, when was America founded? 77? 76?
1777.
Yep, so right about there.
Yep,
they had a decree where they would pay everyone like £2,000 to go to the furthest southern reaches and map the celestials that they see so that they could get the most accurate determination of longitude to a half of a degree, right? But they already could do that based on navigation methods at sea. They had something called the clock stars, right? They had lunar transit methods, and they would say the moon would take a certain amount of time to pass through a star. That would give them a corresponding degree of longitude. They'd also use something called equinox and base the longitude measurements on that. So they don't actually need longitude to be able to navigate anything. Nobody needs longitude for anything. That's just a lie. They could get to where they were going within a half of a mile, really. Within, all the thousands of years, they could navigate the seas based on latitude, based on observation of a Polaris or the sun, and longitude based on equinox, and or where they could get their time component or right ascension component from lunar transit and or Jupiter's moons, right? So they had astronomy methods down to the T to be able to get a component of longitude to determine roughly with their latitude, which is just the angle to the sun, where they were getting and how they could navigate. So the whole story of longitude came from one museum in 2014, issued by the Royal Society, from one WinRAR dump. That was one archive, and all the information I just relayed to you came from that one museum. So that's the history of longitude. Should work, right? But then you got to tie it back to a coordinate system. So like if we had just a map of nothing, we could do grid lines of 1-inch squares, sure. In actuality, the Mercator map as a equal distance projection actually does preserve directions like that, because you can dead reckon. That is the map that you can get on, take a ruler, draw a direction, and then dead reckon that direction. People try to do that on the azimuth equidistant projection. That's absolutely wrong. That's the wrong. As soon as you put a ruler on that map, you're using it wrong. The direction is a revolving cylinder around the central cylindrical axes, right? That's what direction preserving is. And that's how the directions match reality. Or in your case, you can say that's how the directions match the globe. So if you're taking that projection and you're using it with a ruler, then the directions are no longer preserved. They are corrupted, right? So that's not how that works. What I was saying. Oh, grid lines. Yeah. So the Mercator map was a longitude, latitude. It's a spherical graticule, but it's spread out in equidistant 1-inch squares so that you can use it to navigate with dead reckoning that way. So like we could make that. We could say the Mercator map works, but it's just tied to the stars. Everything on our world is tied to the stars, man. Like cosmography was all there was because people understood you can't separate the land from the stars. When they would map new stars, they would find new land, always in that order, never the reverse. Never did they find and map new land and like, oh look, now we have new stars. They only had land because they could map the stars. And when the first map ever was a star map on a cave wall, dude. They'll tell you that on Wikipedia. Then they'll give you a bunch of fake Greeks who knew about longitude and invented everything we needed that sat for 2,000 years, but don't worry about that. Cosmography, and they're like, oh, you know what we're gonna do? We're gonna call it cartography, and we're gonna make that thing it's a globe, and then we're gonna call it cosmology, and no one's gonna ever know the difference. If we only knew cosmography as itself, we would never be confused about the maps, right? All maps are linked to the stars. Now, every time we have a discussion, I have to fight so hard. They'd be like, no, it's based on the stars. Everybody knew this 100 years ago. Everybody knew it, right? Apparently, during the World War II, when they started flying over places, they were using the Mercator, and they were like, guys, this is not what the thing says this country would look like. It's way bigger, right? So they had to go correct it, and everyone was freaking out, like, oh, has maps been lying to us our whole life? Yeah, kind of.
Do you guys think this happens like every 80 to 100 years when people pick up on what's going? Like, do you think this cycles in and out over millennia after millennia, where people think it's flat, then they think it's a sphere, then they think it's...
No, 100% not. I think 2 generations ago, everyone on Earth knew it was flat. And after that, they poisoned our minds. Like, you know how the communists take over a country? Like, they don't worry about you. They indoctrinate your children and get you to turn against the parents. So 2 generations of that, and the kids are having grandkids themselves, and then they've taken over the whole country. Communist ideological subversion works the exact same way. But your great-grandparents all knew the Earth was flat, dude. There's so much evidence that it was inserted late 1800s to early 1900s. All the G's, Alex Gleason, Samuel Rowbotham, all wrote their books 1860 to 1890. And that's when they were like, all the scientists seem to be thinking that it's spherical for some stupid reason, but we know they're retarded, and we're writing these books so everyone can keep it straight. I mean, I'm paraphrasing a little bit, but if you read Gleason's book and you read Rowbotham's book, there's a lot of commentary on science as a whole, and they're like contemporaries, and they're like, we don't know what the hell's happening, but everybody went retarded, essentially. So then you go to like 1900s, and there's schooling, there's newspaper clippings, there's thousands of newspaper clippings talking about flat Earth, there's schools teaching flat Earth, some alongside Globe Earth. There's that Ruth video from David Weiss that always goes into that. That's excellent. Put all that together, and it's like, well, this is a very new deception. They inserted it right after this. All the history that they told us about that longitude bit that I went into, that's 100% fake. None of that happened. I don't think any of that's real, right? If it all comes from the Royal Society and it was all inserted after the fact to give us the appearance of a continuous historicity of globularity. What do you guys think about that?
A nice logical chain of globe evidence.
Historicity of insertion of globe. Yeah, I remember. That is
They
what I think.
wouldn't do that.
They say it takes about 12 years to convince somebody of lies so powerful that when presented with the truth, you will disregard them. And everybody goes to school for like 12 years.
Yeah. Just enough time to completely erase all your family values.
Yeah.
Nice. And like, reinterpret your culture.
So
That's cool.
The kids being surrendered to the state so they can be re-educated into the ways and how they're going to turn in the parents, and then they turn in the neighbors. That's literally how they take over countries.
Is that a better way? Can you tell me a better way to control a populace than to teach the young?
It's the preferred method of indoctrination, they said.
Imagine what you could do if you had that for 3 generations. Like, how much could you change the whole face of the world when no one alive could tell you different?
Yeah. One of the things that I wanted to talk about that wasn't mentioned in this video, but that clip was so complete. I just wanted to use that. But it was the internally consistent systems and ratios. the speed of light being redefined, or I'm sorry, the meter being redefined as a ratio of the speed of light, even though the speed of light starts in meters for the interpretation of it. But so what they did is that you take 1 second over the speed there, and you get basically 3.3356 nanoseconds. And to multiply that back to get the same thing you started with, is just C times the delta T, which is the nanoseconds there. So C times the nanoseconds gives you 1 meter. It's just like they with the redefining of it just fixed it as a constant ratio that can't be changed. So you don't have to worry about like, oh well, if this distance changes, or if the meter changes, or if the speed of light changes, well they fixed the speed of light as a constant, so it's not going to change. And the time interval is just time. So no matter what, there's still 24 hours in a day. Right, like sidereal time is not going to change based on that. So the ratio of breaking the whole time cycle down into fractions of 60, right? That's all. It's all the same system. That's
It's just another unit conversion, right? That's basically what this is too.
essentially, yeah. Yeah, so there's no mutual exclusivity to this. Like it's not like one of the big things that really clicked for me in your prezzies was relating the Eratosthenes story, about how they would have already had to have had the distance between Alexandria and Syene, which would mean they would have already had to have had a spherical coordinate system to have a distance between those two to to then use an angle as an arc in the ground, like an arc across the ground on a sphere to relate that. So like they would have already had to have had that, and then so the way that they say that Eratosthenes method was within 0.1% to like 0.18 or something like that of the accepted values of the dimensions of Earth. And that's only true because nobody actually knows how much a stadia is, and modern scholars agree that it's some ratio of a terrestrial meridian. So so how accurate it is dependent on how much you believe in how close it was to the current accepted value to begin with. It's the most circular thing that could ever be presented to us, and it's just profound
But
that there's never been another thing. Like this is just how you would have to make a system for this, but the way that they've presented it to us is like, like they just happen to stumble across the dimensions of Earth. Like that's
Dude.
the thing that's really crazy. Go ahead.
Eratosthenes is the most circular, but it's the most presented. It's the thing you get taught in textbook. It's the thing that everyone knows. It's the one go-to proof. It's the most well-known thing, and it's the easiest to prove circular. Like, well, how do you measure something by already knowing it? Wait, what? Yeah, like an arc length of nothing is just a meaningless ratio unless you have a real-world measurement on which the ratio is related, right? Like,
Yeah, without anything to convert it, it has no physical meaning. So yeah, that was awesome. And like you said, people were flying over during World War I, World War II, and we're realizing that the map that they thought that they lived on, they made the classic rookie mistake. They thought they lived on the map projection. We've all been there, guys.
I think a lot of people
We've
did it. Yeah.
we've all been there, but yeah, we don't live on the projection, obviously. Yeah, I just wanted to go over that because that was a key feature. So the way that they would present this would be like, oh, this the speed of light is independently confirming, the meter and Earth's radius, therefore, based off of that, but it's not. It's just their input was their output, guys. It's the classic. All right. If anyone has anything else to add to the coordinate systems and such, go
Favorite.
ahead. Now would be the time.
I mean, I just would say like I it's all based on assumptions that those are objects and they are infinitely far. Those are two things that are taken for granted. If it's not just for it to be anything meaningfully tangible, other than optics, things we see in the sky that we cannot explain because we can't measure them or know their chemical makeup, then we have to take those two things for granted, that those are floating objects, or they're objects in a point in space that are essentially infinitely far and straight up from where you're looking, or straight at that perspective, and there is nothing else, no other possibility of those lights being interpreted wrong, being interpreted differently, being shown through a medium. We are just taking them for granted to be objects at those exact points in the sky, and we're using that to make all other assumptions about the ground beneath our feet.
Yeah, that's really the crux of it. And then on top of that is like they're not only are they assuming that it's a physical thing at this infinite distance, but they're also referencing it to a position where it's not even at, right? Because they have a true position and an apparent position, and so to keep their time and chronometer in sync with the coordinate system, they reference the position of the stars and celestial bodies of where they aren't even at to make it work. So then you're
Right.
referencing a ground position on the ground that may or may not even have any physical meaning to where a star or planet or celestial body or whatever is. It's fascinating once
Right.
you really
And then you
grasp
come to
that.
find out, Shane's research comes to show us that it has the logarithmic scale as you come down towards the horizon. Oh, isn't that interesting and convenient? Almost like what perspective would do exactly, and what a globe would not do. The only way you can really explain that on a globe is with a crazy, crazy, gigantic, fuzzy horizon, which completely, like, then you're completely going, like, you then have to accept the apparent horizon. You have no argument about things disappearing over the curve. Like, the whole thing is quite sloppy at best.
Yo, I
Yeah, they
missed
all.
the
Sorry, you're good. Go ahead.
World War One and Two thing. Like I heard you say that they used the projection and then didn't actually know where they were, but I like stepped away.
Yeah, so in World War One, in World War Two, when they would fly bombing routes and stuff and fly over to these different countries, they thought that they would be certain sizes based on the projection that they were using, and then the countries would either be bigger or smaller, and they didn't understand what was going on. I can link you a little media piece on it. Maps are lying to you.
Okay, cool. So World War One and Two was just like a crazy flat Earth era, right? So I mean, you just like got the globe kind of implemented in, and then people went to war where people die and stuff has to work, and just flat Earth kept being what you had to use, or the globe kept not working at least.
Here we go.
Oh, yeah, Battle of the Beam showed
yeah.
that too, right? Right into that.
Exactly.
Yeah. I sent it to you in DM, but I'll also put it in the main chat here. Yeah, there's a nice little 5-minute video on the map situation. It's a nice little breakdown. And then there's also there's been some videos where they talk about how maps were used to like propagandize by showing like a country being bigger than it is and making another country look smaller, like they're trying to bully them and stuff like that. Like, dude, they get crazy with it. They have a lot of fun with projections.
Thank you, brother.
Mm-hmm.
I do think World War One and Two came like right after they introduced the globe and were used heavily to remove and control history, like right around the same time, controlling books and education, burning materials, like getting rid of stuff. With war, it was a good cover. I think that was helpful from the turn of the century until like 1940.
Yeah, I mean, I have a source.
The classic.
I have a source that contracts with the military, and they say that the technology that they produce for the military, like 100% proves the Earth is flat, and it's for planes typically, and weapon systems, And that's how they know the Earth is flat, because what they developed for the military literally has to be over a flat Earth. I can't actually give a lot of details. I don't normally talk about that because I mean I can't. But like I would obviously not make that up, you know. Like verifiably 100% legit. So pretty crazy. So it's like it's still a thing is my point, right? Like when you go to war, like the whole like preference of globe is irrelevant. You know, like either people are gonna die or your stuff is gonna work.
Yeah.
So pretty interesting. I'll see how much
When
I'll
they
do this.
bomb
I will
people.
see how much more of the specifics I can give of the technology. I just think it's like a pretty delicate thing. They don't want it tracked back to them, you know.
No worries.
It's like exactly what happened in Battle of the Beams. It's like they didn't care. The Germans didn't care about what shape it was. They're just like, what geometry do we put in here to make these bombing runs happen?
Right? Can we hit the factory? I don't give a shit. How long can it go? Well, until I don't know. Just tell the pilots to go until they can't hear it no more. Okay, make the factory. Oh shit.
Actually, could tell the pilots to go to the point where they hear two overlapping beams in a triangle pattern. Line of sight.
Yeah, I'm actually, dude, in the documentary, there's actually, I think I signed an NDA, but I don't really care. But the first night we're there, we have dinner, and I debate Mattoon, McKeegan, that short turtle guy, I don't know his name, and Duffy, like 4v1 about Battle of the Beams, and they're just freaking out, bro. They're freaking out. I'm having to teach them what diffraction means and how it doesn't solve the problem. It's crazy. So that's like Battle of the Beams is gonna get some love here soon, I think.
Nice.
Nice. Yeah, we actually updated the radio wave propagation and use all the modern standards given to us by the ITU, using their formulas for spherical diffraction over or diffraction over a spherical Earth. Like, you know, yeah.
Creeping wave. Those we actually need to go back and like triple check those, by the way, because if I remember correctly, I think we like added in like an extra percentage or something for bull night just to make it like, you know, we always give them like the maximum benefit of the doubt or whatever.
Yeah.
I think I remember we like took the standards and added some to the top or whatever. So I think we should go back and like triple check the values before.
So what you're saying is that you fudged it?
Well, only to the globe's benefit.
Yeah, no, giving them like unlimited leeway, the best they could do is have it be below the noise floor at some of these at like 700 kilometers. And so like, you know, that's when they're like, well, if it's below the noise floor, we, you know, they can still hear it somehow. It's like, all right, dude, then what's the noise floor even for then? It's just for funsies.
Yeah, you wouldn't be able to pick up or demodulate a signal that can't be distinguished from noise. That's not how signal processing works.
Yeah. But, you know, to keep the dream alive, got to continue. All right, we got two more. This one's going to be a Man of Stone classic here. And this is on the Felix Baumgartner jump.
Oh, yeah.
And this one is one of my favesies because Stone's motto is about plugging the figures into the mainstream formula and seeing what comes out of them. And these one, you know, when we're dealing with Earth rotation and a guy going up in the air, you know, it can get a little crazy, but this is a nice, straightforward, clean breakdown of it. And we could see not only did he land in the opposite direction, but he landed 40 miles in the opposite direction, if I'm not mistaken. Which is you know, pretty contradictory to a rotating Earth. And then I think there was a follow-up that we can go over, where I think this was covered by Toon. So if you want to talk about that at the end, Stone, you're more than welcome. But yeah, we'll get into.
Oh, sure. And I think the number was 43 miles and change, if memory serves, off to the east.
43 and change. All right, now we know that Stone has a flair for the theatrical. So a lot of the music is copyrighted though that he plays, and this is from a clip from Glowbusters, so there is no music. However, as we're playing it, Stone's gonna sing "Forever Young" by Jay-Z and Mr. Hudson. Stone, whenever you're ready.
Is this a union gig? Where's my freaking agent, man? What is this deal here? And don't give me any of that damn coffee. I don't want that shit. It's about cash, buddy.
Forever young. Go ahead, Stone.
Actually, I don't know the tune you're talking about, so good try. Good try.
All right. Well, we're getting culturally enriched after this, but we'll go ahead and start it up.
We get that we're starting at the middle here, and that he should have gone this way, considering in order to lift off from that runway, it wasn't going to happen until the wind speed was 0 or absolutely close to 0, stable, if you know what I mean. For matters of safety, strictly for safety reasons, they had to make that call, which they did. And the wind was pretty much 0 when they let him off that morning. All right. So at that moment, what I didn't draw in this diagram is another arrow from right to left to indicate the Globey assertion that the Earth is spinning while all of this is going on at 15 degrees per hour. And okay, my bad. So since then, I have actually put together a little GIF just to demonstrate the principle from which I took from Dave Weiss, actually, who pointed this entire thing out about losing position as you increase altitude, and it's all a function of R, your radius, your altitude from the center of the allegedly spinning Earth. That when we deal with tangential velocity, whatever it is when you're on the surface of the Earth, as your altitude goes up, so does your circumferential circle of motion, that it becomes a longer line than the line we draw on the surface of the Earth as globies. Well, this is the little graphic that I put together recently so you can get it. You can see that as the Earth continues to spin after he lifts off, he continually loses ground from his starting position, because all he's doing is 0 wind straight up and has no extra lateral, or in this case longitudinal, impulse. No way to speed up and keep position with what's going on the ground. This is the fundamental geometric premise of everything that's going on, or what you're about to see with the numbers involved, the spreadsheeting, and all the stuff that most people just tune right out. It's right there. He's losing ground because all he's doing is going up. This is how it should happen according to the globies. Well, don't you know, it didn't. And not only did it not, it happened in the other direction several times over. I mean, 6 1/3 versus 44 miles in the complete opposite direction. Here it is when we're looking at the top view now. Like here, we are on the north side of it looking south, and the Earth is spinning allegedly right to left. Okay, well, when we're looking at the top view, and with Google Earth, you just tap the N and it puts north up. That makes east to the right. That should be the direction Earth is allegedly spinning, because we see the sun go to the west, right? So that just makes instinctive sense. So when we look at the runway over here, this is where the airport is at the bottom of this spike, and we look at where Felix landed. He landed 4.4 degrees north of due east. Due, geometric, earthbound, latitudinal east. And the distance there is 43, I don't know if you can see it there, I put it down below, 43.77 miles exactly. So there's no fudging around about did he only go 30 miles or did he do this or that. No. That's how far he went. And again, this is the outcropping we're seeing in all the frames in the video that I present. So in doing calculations about his circumferential circle and how with altitude that increases and becomes a larger number, we need to know what the original number is across the surface of the Earth according to the globies. So we go to Google Earth, don't we? And at 33.1 degrees north, which is exactly where we're at on runway, whatever number that is, we draw a latitudinal line all the way across Earth, and you use many points to keep it, fairly honest. And when you do that, you find out you get a distance of 20,800 miles. That it's not the 24,901 we have at the equator, because we're up here. We're at 31. What is that? 33.1? Yes, 33.1 north. So this total circumferential line across the surface of the Earth, according to Google Earth, is 20,800. And in my spreadsheet, you will see me use the number 20,802. Just because. And I think that's where we're going to go next. Did I leave anything out? We did the pressure thing. All right. And
we got a question in the chat.
Oh, by all means.
Do you know how far, or do you know how the angular displacement that the Earth should have rotated out from underneath them, or how many miles it should have been rotated out from underneath them?
Oh yes.
Nice,
We're about to go over that. That is what the spreadsheet is all about.
Nice. A spreadsheet, you say?
Oh, you want figures? You're about to get a double scoop, bro. Okay, so let's just go there now. When we deal with that average feet per minute, that's something where the human mind just can't really grab the abstract figure and understand what that means in physical terms, relatable physical terms. So it turns out that that's an average of 9.5 miles an hour straight up that Felix was going. Now, when you look at that, again, against the pressure diagram that I just showed you, and dealing with that it's a balloon with a lighter than air gas inside the balloon object, and that's constantly expanding, we have a lot of variables to argue about back and forth, which are all essentially meaningless and tertiary to the argument about, what was his maximum feet per minute going up? Well, that might have been as much as 30 miles an hour. What was his minimum? Well, that might have been a minimum of 1/10 of a mile an hour by the end of it. I don't care. But the point is that these are the averages, and we're just going to deal with that from that perspective. There might have been more at this time or less at that time, but I guarantee you the answers that I'm showing you are going to be roughly the same in where we actually end up. So ground traveled in degrees. This is just a straight up compilation with H14, which is over here. I'll show you how we get to that in a sec. This is the arc of travel, the longitudinal change, so to speak. When we saw in the graphic, in the animation I just showed you, with the capsule leaving the platform and going up, and while it's losing ground on what's going on, what is the actual change in arc, in longitudinal change? Because we're going with due east. Maybe he was 4.4 degrees off of due east. I'm going with due east, and I don't really care about the 4 degrees. It's not part of the argument. The question is, where is he in terms of the rotational speed of the Earth? You know what I mean? Where is he going? How much is he losing is the question. Here, we're talking about the root figure. Okay, that's what the ground is doing in 158 minutes. Well, physically speaking, at 33.1, that works it to 1,739 miles. Okay, great. Well, the 2999 is the tally of all of these arcs, minute by minute, added together. What we're looking at here is about 1/5 of a degree of arc change in movement per minute. And when you add them all up, here we are down here, 29.9876 millionths of a degree, if you want to really get that accurate. This is the only column where I showed 6 digits to the right of the decimal, because the increment change between minute to minute is so small. 10 millionths of a degree kind of thing on average at the start anyways. But the point being that it's 29.987 whatever, and that rounds up to 29.99 degrees in the tally. And that's close enough. Hundredths of a degree, guys. Let's not be dickering beyond that. Okay, so that converts to a number of miles. And when you subtract it from what the ground was doing, Felix lost 6 1/3 miles of rotational arc. Right here. This is the 6 1/3 miles that he lost. As he went up, the Earth continued on its speed, and he had allegedly that same speed, not talking about wind at all or anything. He will have lost, because of his increase in R, he will have lost that much distance.
So yeah, he would have lost 6 miles in the east direction, but instead went to the west by 43 miles.
Man, the Globies have got to be feeling a lot of pain watching me drag them through the coals so deliberately like that, you know? I kind of feel for them, but wait a minute. No, I don't. No, not at all.
Yeah, that was a classic, and that was a hot argument back in the day when that came out, but nobody really put the figures to it like that where it's indisputable, you know?
You know, it was coming up on 2 Friday nights ago when a dude named Zach was actually on the spaces on Twitter talking about this and saying, no, man, yeah, I looked at it and I thought about it, and it's not right. And what about wind? And, you know, what about my math? And I
Thought
said,
about
okay,
it.
I'm sure you did. I'm sure you remember that guy. And I said, look, okay, go take care of your 8-month-old. Stop playing on the phone when you should be paying attention to him, and bring your math to us next week. What do you know? Crickets. His assertion had to do with how wind must have affected it and blown it those extra 40 or 50 miles out if you add the two, you know, if you sum them for error. But the problem is, in his math, he wasn't having any appreciation for density decrease in the air itself with altitude, and that it drops sharply. And forget about it when you're 24 miles up. There's just no wind up there to push on you. And so, naturally, once again, we have not heard back from the Globie.
Unlucky. I don't think I've ever heard back from anyone that has presented this, except for there was a recent review of this that was done. But if I'm not mistaken, the argument is kind of nullified because there was a unit conversion that wasn't done, and the units that were presented in were the same units that you said it was. So it was exactly as you said, but the person that was reviewing it misinterpreted it.
Yeah, that'd be Goon, I think. And he tried his hardest to tear that presentation apart. And it made for an excellent pair of videos. Or actually, I think I said corrected. A single response video is what it came to. Where
is it on your Rumble?
It's
Cool,
on my
right?
Rumble channel for sure, where he pretended to pick apart the presentation, and I kind of dissected that a little bit and prepared responses to it. It's rather entertaining. I think you're gonna have to go right to the end of all 3 pages of my videos to find it because of the order in which I uploaded everything to this account. Yeah.
Oh, that's why I couldn't find it.
See, they're here. There's those 4, and then, you know, a few
Page
more
2 maybe?
later on. But
Yeah,
I'm pretty sure that's what we were looking at.
Yeah, I couldn't find it. Where's it at?
Again, to page 3. I don't remember which one it is again. You have to take a chance to see which one it is. It's I think it's actually Toxic Clown. No, wait a minute. It's one or the other. It's either Toxic Clown or Human Trash. And I think it's actually Toxic Clown. The Human Trash is one where he just goes ballistic on a guy he's debating on his own stream who tears him up.
Nice.
Yeah,
Yeah,
this
all right.
very well could be it.
But yeah, so what was the scenario that happened there, real quick?
Well, that's what that video is about. It's 7 minutes. It's all about how he spent an entire 2-hour stream cutting us up actually as a group, as a Globebusters group, and he spent a considerable amount of time, about 2/3 of the way through the stream, on the Felix video as I presented it, like we just watched it, and he just sat there all smug and commented on it as comments went by, to the best of his limited ability to somehow discredit or debunk what I was doing, and including stuff about well that's why there's wind, and it was really comical. It made for awesome entertainment, I should say.
As long as he smirks condescendingly, his audience seems satisfied. Thus, he has debunked whatever he's showing. I think that's how that works.
Oh, for sure. And then just add it to the super chat pile.
Yeah.
The classic. Yeah, that was good stuff, man. Really really took the argument home by showing the figures for it, which nobody had done
Thank
prior.
you.
A lot of
I
it was
would
just
say.
assertion, and like, you know, like we all kind of felt like it should have went like why didn't it go in the other direction? You know, we all felt that, but like to see the numbers to it, it's just like, oh yeah, that's not what happened at all.
Totally. I still credit Dave Weiss for the original assertion, the guy who said it first, as far as I'm aware of. But yeah, he is the inspiration to do that, to get, to fully quantify what's going on, to get into the video that they've released for us back in, when it was, 2014 or something now, how time flies. And to just get out the micrometer and slice it up, and here's what happened, and geez, you know, that just doesn't add up. That's amazing. And frankly, I like to take this moment to be the first to recall how things went in the past year. And I would say, what a wild ride. This particular presentation being a small highlight in a vast collection of highlights that we did on Globebusters this season. That was just sublime as an experience, I must say. And interesting, also notable that you, and timely that you point out my method here, that this is something I've relied on in the creation of a lot of my content, and I must now applaud y'all for adopting it this season in your own presentations and deliberately citing it, saying, hey, we're going to use the stone method to tear this guy a new asshole. And then you confidently proceed to do exactly that. And yeah, big congrats on taking that step.
It's been fun.
That edification of what it is. That was awesome to see.
Yeah, if you're not plugging in their figures into their formulas, I mean, you're not even really doing it right or whatever. So,
well, you're leaving the low hanging fruit, apparently, is what we found out.
You gotta call their bluff every time, man. Call their bluff.
Yeah, there's levels to it. So it's like we started off with, yeah, that doesn't seem right, and then we elevated to, my man made a spreadsheet, showed the angular difference over time as adding up incremental angle changes as he ascends into the heavens. It's like
totally. I'm going up against Globies are all like, it's kind of a little bit, it kind of went up fast, but might have been some wind, but I bet it was this. And I'm like, screw you, buddy. Here's the figures. You know, here's the measurements. Here's your formula. Deal. And yeah, it worked every single time.
Yeah, it's been, wind came and blew the other direction 13 miles. That could happen.
Well, I don't know, that when you look at the bigger picture of that Felix video, it's almost a dare. Like we're leading the witness in the trial to bring up that subject. We're just waiting. Say it, come on. And Goon actually did. He said, well, that's the wind, dumbass. And that's precisely what I was waiting for them to say, if you might think, is that, look, yeah, something moved Felix to the east, 50 miles from where it should have moved him, given the basic physics with no wind. Well, okay, if it's the wind, well, hell, the wind is always farther above the ground than the ground. The wind should always be losing ground with respect to Earth's spin. We should experience nothing but easterlies. Nothing, or westerlies, I should say, because of the direction that we're. No, easterlies. I take it back. I said it right the first time. The wind for us should always be coming from the east as the Earth spins towards the east. Yet somehow, I mean, excluding the point which I ran into early in the video about, hey, convective cells and the stuff that Goon was drawing in his response, all that business happens at 20,000 feet and under in altitude, about 20K. But you see, when you go up even as high as 40, 50,000 feet, the wind speeds up there, although there's not a lot of mass to it, and I think that's part and parcel, which you'll see in my lecture on electrical thoughts, that this is the jet stream we're all talking about. And it's constantly doing 300 miles an hour to the east. and what is causing that in the Globee model? What exactly? Even more so that at the same time there'd be another wind at about maybe only 35,000 feet up, doing about 150 miles to the west simultaneously. This is the mechanism that all the balloon launches are taking advantage of in getting around to to survey and measure the correct part of the sky where they want the balloons to be for positioning. They take advantage of this. How is that going on in the Globee model? What's the thing that's generating that mechanism? They simply have nothing. It's a joy to watch them squirm.
Wasn't that the title of his video? Was we don't understand wind, and that was the crux of his whole argument for however long. It was wind.
Quite right.
Wind did the whole thing. Wind blew him off
Quite
course. Wind
correct. Yes.
counteracted the spin. Okay, I was just reminiscing correctly.
Did he at least have a spreadsheet to show how much wind?
Hell no.
Nah, he just said wind a bunch of times.
Unlucky,
he went the
dude.
Jesse passive shit route. He picked up his felt pens.
Unlucky.
And drew a little 2D bop 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 bop, and that was it. Case closed. It's a globe.
Oh yeah, dude. You know when you get the pens out, it's a wrap. All right.
Yeah.
But yeah, dude, that was awesome, Stone. And yeah, the philosophy of applying their numbers and figures to their formula is, can't be understated.
So was our Allen clip, dude.
Overstated. Can't be overstated. It's extremely important. Oh, Allen clip. Forgot about that.
Here.
All right, 1 second.
Did you pick out your own clip?
Of course not. I wasn't even going to do one for me.
In any case,
You're welcome.
Thank you, chat. That needed to happen. Overruled, as they say.
But you guys are in luck. Mine's only 3 minutes and 36 seconds. So
thank you for being here. And Alan, thank you for going out there and educating.
This is, for context, this was after, I think it was my second debate with McToon on general relativity.
All of us so much about general relativity.
Violently or whatever.
Dude, my absolute pleasure, dude. Growing up as a young lad, I used to be a relativist that didn't understand a gosh darn thing, but I was told that Einstein was the smartest man in the land, and that his theories told us how the universe works. And then I grew up and started reading about it, and I found out that there was a giant deception uncovered regarding how light functions and how bodies in the sky move. And it all seems to be tailored around a certain coordinate system that's always referenced. So, it's been fun going through all that and dissecting it and making it digestible and going through these so-called proofs that are touted as mutually exclusive to a theory that provides no new physical insights to reality and just is a patch to a previous explanation that was failing because, all of these theories And motions, or I'm sorry, all these theories are dependent on motions, right? So you have to have some velocity somewhere. So in 1887, when people tried to start measuring the velocity to confirm the correctness of their model that they believed in, they found that the Earth was stationary AF. And that was a huge problem for them because all these lads grew up thinking that the Earth was just sailing through an empty vacuum, nothing, maybe medium, who knows. But they all were committed to the idea that the Earth was in motion, and that the dynamic cause of this was, at the time, they thought mass attracting mass. When they didn't get the measurements that they needed, they were like, well, that's a rap skis for that. How can we confuse the hell out of everyone? And this was right around the time when absolute differential calculus was popping off. So they all hopped on board that and started transforming to infinity. And now we find ourselves picking up the pieces.
All this when you were a child. Amazing.
Dude, what happened? I blacked out. Honestly, I don't even know what I said. But I think that's a pretty accurate recap of history. And yeah, the theory is DS, and that's how easy it is to expose it. You just have to read the history of it and find out that nobody knew what they were doing or what they were measuring, and they were just conforming equations to reality to maintain a stranglehold, a monopoly, if you will, on your mind and how you see the heavens. Those things in the sky that are for you, that are all apparent to the person, those are for you, and they've monopolized your thought and how you conceptualize them. Because as we went over in the debate, the math they're attributing for the displacement, for the things that they talk about in the sky, they have no causal mechanisms. They just have ratios for things. Stone, what do we know about ratios?
I don't know, but I think it's about time somebody gave Alan his $200. He's around that end of the board there, so fork it over. Little Monopoly joke. I guess you guys missed it.
Oh, dude, thank you. Yeah, I totally was like, I don't know what's happening.
Which ratio were you talking about there?
Well, just any. When you start ratioing things to build a model off of it, you can literally just, as long as you can get back to that original ratio of your description, you can build, an entire role play off of it to describe interactions on subatomic or on the macro level,
or the sun moon visual perspective. Any of them, yes.
Any distance, any mass, all the way through to like whatever infinity you want to.
Even parallax.
Even parallax.
It's fun to revisit some of my old jokes.
But yeah, going through, dude, I had no idea what it meant when he said it, and then I realized that I said monopolies twice or whatever, like 30 seconds ago. But yeah, in any case, the significance there of using a system of mutually reliant ratios is what has constructed this matrix that we live in. And as Shane was talking about earlier, everyone knew the land and the stars and everything together as cosmography, and those two things have been separated into different fields and like compartmentalized in a way where you don't realize it's part of a whole system. And we have these different components that are supposedly working together and finding like mutually or like confirming the model through independent means, but they're not. They're just working with ratios of the model, and their input is their output. So it's pretty simple. And then anything that diverges from that gets corrected as an error, thrown out, so on and so forth. I mean, when they started taking geodetic surveying, right, if the stars didn't line up, if they didn't cross the meridian at the time that they were predicted to, they just said that their plumb bob was off because of gravity. They just said, how much would we have to have tilted it by for it to have passed at that time? Oh, that's how much gravity is off. Like,
deflect that vertical, yo.
Well, there must be some extra mass in that hill right over there.
Dude, the extra mass in the hill is crazy. There's
off your sleep patterns.
Yeah. Oh, dude, if you're not perpendicular to the geoid, you're gonna have real problems, dude.
I can't be sleeping on an incline. What is that?
That's one of the funniest songs ever.
All right. Yeah, and with that, we're gonna play a couple of messages from lads who couldn't be here at this time due to prior engagements, so on and so forth.
Did they
So
get
we'll see.
drafted or something? They in the military? Like, should we really feel bad? Like, wow.
I'll start off with our president, JT.
He's just stuck doing the dishes perpetually.
Let's
Whenever
give
going to
this
see
a
him
shot.
again.
He's running.
Could be doing the
Yep.
dishes in the video.
Here we go. I think there is a dish in the video. Here we go.
Nailed it.
God. I may not be able to hold on to the baby. She wants to run off. I was gonna hold her, but oh, you just want to do okay. She'll do her
the
trick
yard
and then she'll
that
run
big,
off.
can you
Okay,
blame
show
her?
me your trick. 1, 2, 3. 1, 2, 3. Okay, go. She said 1, 2, 3. Hey, I just wanted to holler at y'all and just congratulate you on 3 years. It's been an amazing journey. I sort of didn't realize that much time has passed, but when you're seeking the truth in all things and uncovering deceptions and inversions and like untangling just the web of lies, time goes fast. You're having fun. Thank you guys for all your hard work. Alan, you've just crushed absolutely on how much knowledge you've gained and presentation skills and debate skills. You know, Stone's just really done a tremendous amount of work. You can find him on Rumble, just Man of Stone FE or Man of Stone Flat Earth, I think is a good way to find him. Shane, since I met you probably 4 or 5 years ago, you've been crushing your channel and your contributions. I know Piezo drops in from time to time. Just all the lads, the people that are the regulars that chime in as well. Much love to each and every one of you. I feel like you're my brothers in this, and it's really fun. It's fun not to be afraid of just the drama that gets stirred up when you talk about, you know, cosmology and where do we actually live and what's really going on with the ether, and there's many other topics that folks are digging into these days. So thank you for the hard work you've put in, the dedication, the hours logged. I mean, I really wish I could tune in on Discord for the all-nighters. That'd be awesome, but you know, I've got my hands full. But yeah, that's all I had to say is just I love y'all. Keep it up. I'm really, really proud of you, and carry on. President out.
President out.
Dude, that's when his cameraman was supposed to cut it, but the president had to do it himself because we don't pay him that
For me.
much.
What an absolute legend.
We
That
love you,
was awesome.
JT.
But yeah, it's been an awesome journey, guys. And, you know, I love sharing new things with you guys, and I love learning new things from you. And it's been awesome that we've built this community together.
Dude, and cheers to the spite learners and the trolls who inspired Alan to learn relativity in the first place just to prove him wrong. Cheers to that guy.
Fight learning is the best.
It's like, you don't understand. All right, give me 24 hours.
Hey,
Let me go look at
El Presidente has just arrived. We just played your clip, JT, like just seconds ago.
Yeah,
Thank you for all the kind words, JT.
Well, I wanted to mention I did multiple takes, and a couple of the takes I shouted you out, Toby. I was like, Toby, you're a legend. You're still crushing. I know it. And then that one I didn't. Sorry, bro.
Oh, you're
he
all
immediately
good,
felt
man.
bad.
No, of course you did. No, you're all good, man. I mean, I haven't done much. I mean, it's been a lot of other people, Alan, Shane, Stone contributing. I mean, a lot of other people carrying the torch.
Yeah, but dude, seriously, the light that you carry and who you are is making a difference in the ether, in the world, in reality, for the truth journey. It doesn't matter if you're on Discord. It doesn't matter if you're doing YouTube or like you're alive and well, and our brother and everybody that shows up, everybody that comes and goes. Like we're all really doing bigger things than we know. I'm up here at my wife's, parents' house and trying to get the baby to go to bed, but I had to pop on real quick to.
Well, thank you.
That's
Yeah,
awesome.
thanks for
Thank you,
playing that,
JT.
and y'all enjoy the rest of the celebration. Some of it, but yeah, love y'all. Take care.
Yeah, have a good one, dude.
Later,
Thanks,
El Presidente.
Later, brother.
JT, bro.
Immaculate timing.
He was
Hey,
watching.
Alan G, I had a few words to say whenever it's
Oh yeah,
appropriate.
absolutely. Good. Yeah, go ahead.
Well, in the alphabetical, it stands J, K, L. You're next. Yeah, go ahead.
Well, I just wanted to say congratulations on the 3 years, and that I so appreciate all of you in this group, this Ether Cosmology, because you guys have intellectual honesty. You put in a lot of hard work, and you bring very real physics, with all the citations and all the common sense and the critical thinking, and most important is the intellectual honesty. And I think that you guys have brought the science as far as you can, on the budget that you have, and just your sheer hard work of really disproving all of the, or showing all of the holes in the globe theory. And I want to say that the science has been very useful in shape, allowing me to shape uh reality better. And now that I'm free of the whole globe illusion, I just want to say that, on a spiritual level, I have been so much happier and so much more fulfilled as a flat earther, because I feel like, since I discovered the flat earth, and since I discovered that we're in a finite, most likely like a, some kind of an enclosed universe or world, I'm just so much happier, just from like an emotional and spiritual perspective. I really hated like this deep, dark abyss of this never ending infinite space with trillions and trillions of miles between us and all the stars and all that garbage that we were fed. So I want to thank you guys, and here's to many, many more years of, more discoveries. And hopefully, by God's grace, somehow we get the budget to move further and get more and more like real physics proof for being a stationary and flat earth. So thank you. I really, really appreciate you guys. And folks, go to that Ko-Fi accounts and sign up, for subscriptions, because I think that's really a great thing to do to support all you guys. So thank you so much. I feel like I'm in you guys' debt. So love you guys so much.
And that wasn't just the brush tail coffee talking. That was from the heart.
Not that time. Yeah. That's great. Thank you, Lily.
Yeah,
Thank
yeah,
you,
thank you for
Lily.
all the kind words, Lily.
I mean, I have GPS Glock questions.
What you got?
So, okay, because I mean, everybody I talk to from the mainstream, whether it's ZZ Pop, Ingersoll, Bull Knight, they don't really have a rebuttal for this argument. And it's the argument that you guys are probably familiar with it. The one where it's a video of him and he's giving a presentation and like the slides aren't all the way on screen, but it's pretty much these GPS clocks, they simultaneously correct for uniform acceleration effects and uniform gravitational potential effects. And relativity says that both of those cases should be physically indistinguishable locally. So it refutes
Well,
relativity.
oh yeah, you're talking about the clip of Ron Hatch giving a seminar on atomic clocks on satellites, right?
Yeah.
Yeah. So so the way that they say a satellite works, right, is that it's in free fall around the Earth, and then they consider that an inertial frame if you're in free fall, because general relativity makes the equivalence between being in free fall versus being in a gravitational field. They're the same. So in any case, if you're in free fall, you're in an inertial frame. And if you're in an inertial frame, you should measure the speed of light as a constant. But what they found is that they have to account for the velocity of the satellite itself, in addition to uh, uh, gravitational potential corrections that they say. Well, actually, no, they actually don't make those. So the one thing that they do, I'll get to that in a second. So the one thing that they do for sure account for is that the clock loses time as a function of how fast it's moving, and that's not supposed to happen. That's the Sagnac effect. That's not supposed to be a general relativity feature, especially if you're in free fall. But the two corrections that they say that they should be correcting for, which is gravitational potential and Earth rotation, I believe, for some special for anyway, they don't account for either of those. They say that they basically cancel out.
Oh,
So yeah, like I can give you a GPS overview document from the, I think it's like early 90s, 1995 or 96, where they
so
talk about this.
okay, so the more potential you have, the faster the clock is supposed to run, right? And there's like a proportional relationship.
If you're further
More
away from the
potential,
gravitational field, the faster your clock will run. Yeah.
right? And then the faster you're going, your velocity, the slower the clock is gonna run,
Yes, sir.
right?
Yep.
Right. But relativity, the strong equivalency principle says that both of those cases, those accelerations should be physically indistinguishable.
Well, the velocity itself isn't even an acceleration. So like it's free, like it's not accelerating or anything in general. It's moving at a, constant velocity
It's
almost.
inertial.
Yeah. So they wouldn't even apply any correction for that anyway.
I thought they like did a pre-calibration. Like if they know they're gonna put it up and it's gonna be, orbiting at a certain velocity and then a certain potential, they're pre-calibrating and correcting on the ground before they launch so that it operates with the correct timing when it's at that position.
I just had a thought, Alan.
Go ahead.
An
Didn't hurt.
accelerometer doesn't register anything in free fall, right? But what about if the satellite is doing circles around above our heads? Would we not expect the accelerometer to register the constant change in direction?
Hmm. That would be like a tether ball, right?
Yeah.
Yeah, I would suspect some.
To answer your, sorry, go ahead, Locke. You're good.
No, yeah, I think PA's if it's moving around that central point and it's in a curved path, there's gonna be some coverage.
Right, because the
Yeah, and
reason
to
it's
add
supposed
something
to not
else. Oh, sorry.
but
Go ahead.
the
You're
reason
good.
it's
You first.
the reason it's not supposed to register on glob world is because it's technically always pointing inwards towards the center. So in terms of that, like they treat it as always moving in the same direction about the center. And it's not changing because it's falling through this geodesic thing that they make up, the curvilinear path or whatever. But I feel as if, do we have, access to accelerometer reading on satellites? I mean, Dr. Mike. I just realized he was.
That's an easy no.
As you know, I can't speak about anything related to satellites.
But you hear about,
I
if
have
they're
too
doing
much
circles above our,
information.
they're doing circles above our heads. Wouldn't we expect there to be a? This is a theoretical question. It's not a. Do you know something? Would you not expect an accelerometer to register something doing circles above our heads? Because it'd be no different than doing circles on the ground, right?
So yes, I would expect it to register something, and then I've been digging a lot into history lately, and something I didn't realize until recently is that Hendrik Lorentz, when he came up with Lorentz contraction, that was to explain the luminiferous ether. It wasn't to explain Einstein's theory. And it just so happens to make exactly the same predictions that Einstein made with the theory of relativity, which means
Yeah.
truly you can't tell by those things whether there's a difference. But you can think about other things of what would be different. And on a globe Earth, a satellite would be traveling in a circle around the Earth. But on a flat Earth, it'd be traveling in circles overhead. And that should change acceleration vectors.
Yeah. That's what I
Now,
was thinking.
I can't confirm or deny whether that happens or not, but in theory, that's what should happen.
Man. If only we had some accelerometer data to look at.
If only.
So what was a
And-
trip whenever I took all the satellite data and I put it over a plane projection? Like just naturally, a lot of this, like say the ones that change altitude significantly at apogee and perigee, like when they get lower in altitude, they speed up significantly in the south and at lower altitudes.
What?
They should be speeding up at higher altitudes.
But they weren't, I don't think.
What?
That's
I think
crazy.
I think it was showing, assuming that the script is written correctly, right? It was showing that as they decrease altitudes, they sped up. And so what was interesting, right, is because if you look at it on the plane, obviously the south gets stretched out, right? So their like route when they're in the north, they're at higher altitudes, and then when they go to the south, they're at lower altitudes.
Are you
Which is
talking about
crazy.
altitudes like going from up to down, or altitudes like making the circle?
Yeah, like from 600 no, like from 600 kilometers to supposedly like 40,000 kilometers at apogee and perigee, and when they are the highest, they're in the north.
Yeah. Yeah.
So is that just coincidence? What would be the altitude relationship with the south on the globe? Because
Well,
say in theory that you needed to go faster on the south, right? In theory, like if there's like a vortex around us, in theory, you would possibly change altitude in relation to like maximum inertial forces, right? Like you would have to have access to data that none of us in this, well, as far as I know, none of us have access to, right? I mean, you'd have to know where maximum centrifugal force is based on a lot of variables that we don't have, but
Well,
if it was
regarding that particular satellite, if you go back and make sure you have a long enough data set, check for any kind of precession or gyration of the semi-major axis of that orbit, apogee to perigee, if you know what I mean. Does that orientation change with respect to North Pole orientation, the axis orientation over time, or is it static?
good question. I actually don't know the length. I don't know the duration of the data set.
Yeah, that's critical right there.
I mean, I'm
It
thinking
might
of
be
like
a
a
year.
rubber. I'm thinking of like a rubber band thing, right? Like if you imagine a ball, right, and you have this offset oval, it's like a rubber band kind of stretched out a little bit, where it's like really far past the ball on one side and just barely past it on the other. Like in the far side stretched out as the north and the side barely past as the south. And as this thing does, it's like oval when it traces the oval over the north, and it like slows down at the north and then changes direction, comes back the opposite way, and then it starts to speed up. And then when it gets back down to the south, it like does the same thing, but at a much closer distance to the Earth. You would think if that was the model, then technically in their model, since it's in the south, it's closer to the Earth, the gravitational pull in the opposite direction will be stronger because it's a closer distance, so it would accelerate faster to the opposite direction when it flips direction from south to north rather than north to south. So I would assume.
Given it doesn't flip like he's saying, I can't remember because obviously these things are completing their path like very quickly, you know,
Yeah.
and then it just loops it. I just assumed that they continued the same, because obviously if there's satellites, if this data we're getting is legit, we obviously know that there are corrections applied to it that's already been demonstrated, right? Like the Sanya correction and all this stuff. But like where they claim it's raw and it's not actually raw, whatever. Just set that aside, like just in a very meta, right? Like the satellite's gonna have to go much faster in the south than in the north if it's going over a flat Earth, right? They're gonna be doing these ellipses that are going much faster around the south because they're traversing a much greater distance, right? So like, it kind of does make sense though, right? Like if you were to think about if there's like a rotating universe and you have the inertial forces of like the Coriolis force, so like a centripetal force, then you have the centrifugal force. If say there is some type of containment, say there is like a vortex, if you were to get closer to wherever that
edge,
I mean theoretical edge is, yeah, then you would catch that like centrifugal force.
It'd be stronger at the edge of the whirlpool because the tangential velocity of that whirlpool would be faster out there.
So trip about it though is like if you were able to, I mean, the idea of just taking it as a globe and it just working seems kind of far-fetched, right? I mean, in terms of knowing the proximity to the centrifugal force. I don't know. Anyway.
Man, now I really want to know if there's like public accelerometer data for satellites. Like, what about people who send up CubeSats and stuff?
A new thing to look into.
Not fit for purpose.
An accelerometer that keeps a log, keeps data in a CubeSat would be interesting.
Like what, in theory, getting it back, right? Because obviously all the data is kind of ran through corrections, right? I mean, it's inescapable.
Right, you'd want to send up your own encrypted software.
Yeah, there's so when like universities and amateur teams send up CubeSats and they launch like the big boys launch them for them, right? But then they're like the team or the university's CubeSat goes up, they have they're given a GNSS module that's able to operate at those altitudes because regular civilian models won't. But as far as the other hardware on board, I was under the impression that like the other hardware on board, they're allowed to use like some of their stuff. So I know that there's like a hardware chain. Who is that guy who works for Amazon satellite team who comes in here sometimes? What's his name?
Guy
Anyways,
McGuyerson, I think.
yeah. Anyways, from talking to him, I know that they have like an approved. Yeah, Josh Ingersoll. Yeah. I know from talking to him that they have an approved hardware manufacturer list and hardware model list of the stuff that they're allowed to send up. Like the hardware that they send up actually has to be cleared first. Like I think they're only allowed to use like ITAR cleared stuff and blah blah blah. Like they're picky about it. So
I just Google searched and it says that yes, certain scientific satellites carry high precision onboard accelerometers. Key satellite missions GRACE and GRACE-FO. The Gravity Recovery and Climate Experiment missions use twin satellites equipped with ultra-sensitive electrostatic accelerometers to map tiny changes in Earth's gravitational field. There's another one named Swarm, the European Space Agency.
Milligals, no doubt.
Yeah, so they do have accelerometers on these things.
no, I know they have them. I'm talking about us being able to like see
The
the
data
data.
public. Yeah, because I remember I was debating a guy back in the day, and he tried to portray it that like, you know, he just built a CubeSat in his garage and shot it up or whatever. But like, But what I'm trying to understand, right? Am I tripping here? Like when you're trying to get the position of the satellite, you're going to use ground stations. It's just going to be run through the WGS84 for the ground station's position in relation to the satellite, and then the ephemeris, and then the satellite's going to send it down to your receiver. So even if you put it up there, you're still at the mercy of the corrections that are applied to it before it gets back to you.
Yeah, that's from the GNSS module, right? The global navigation some support system, whatever it is. It's like GPS, but the global one, because GPS is technically American, but like the GNSS is the worldwide version that everybody collaborates on. When you have a GNSS module, that's the thing that talks to the GPS networks and tells you where you are. So that gives you your lat long, altitude, all your positioning stuff. But in theory, the accelerometer should just be a standalone piece of equipment, part of the sensor fusion package that sends its own data within the data stream.
Or even
okay.
just store it locally.
Right.
Well,
Storing it locally is interesting,
Oh,
but
you
what do
can't.
they?
Do you get to retrieve anything afterwards?
Oh,
You
that's what
don't, do
I'm.
you?
That's what I don't think so.
No, they have accumulated data that's registered locally.
Wait, but
that you
I'm
can look
saying
at.
like we're talking about the device itself on board, locally storing it, like cold storage,
There's no
basically.
retrieval. There's no way there's any
You'd have to
retrieval
retrieve it.
devices.
Yeah, no, there's no way. They say it burns up or falls in the ocean or whatever.
So yeah, you have to have your own encrypted stream of accelerometer data.
Well,
You guys want to just go rogue?
The antennas.
Supposedly you can get you can get access to the data from Maven accelerometer data, which is on the NASA Open Data Portal.
Right. Our idea is we want our
Okay,
own,
let's
we want our own
okay.
accelerometer. Is the point? We
brother.
want to corroborate NASA and prove that they're right.
Yeah, I mean, I would think that, like, what's the communication? Like when you have a CubeSat up, right? Like the university is allowed to communicate with it because it has its own antenna and they have their own receiver. The data that they get from the GNSS is already pre-processed and fed from the GNSS network to the satellite before the satellite streams it to the ground. So like that's how they do their positioning stuff. So that's all hunky dory with them. But as far as streaming their own peripheral data from
Why would
the
they let
satellite,
you do that?
well, they already check out what hardware you have on it before it goes up. So they only approve, like, you're not allowed to just put your own cameras and stuff. They won't let you do that. But
I'm saying, but why would they let you just get raw acceleration data? We know that they have a major problem with the acceleration data. You know what I mean? Like, just their model fundamentally. Like, even if you go over in stationary globe world or wherever, right? Like, they just relativistically have issues.
Can't we just, for science, corroborate them with our own encrypted stream with our own accelerometer? Wouldn't that be great for science for everybody? Shut everyone up.
yeah, dude. I mean, that we need
That's
like
what I
an
would-
FE. We need an FE satellite launch and you send up
Let's
our
do it.
own
Let's
satellite.
just actually set it up, dude. Let's set it up. I'll raise money for it.
Sounds like a plan.
Well, if
I'm
we know
already
that
I'm already
these
certifiably a Mason to everyone. So if I shoot up a satellite, it's not going to change anything.
Well, you wouldn't shoot it up. You would just provide it, and they'd piggyback it up there, you know. But
Yeah, I'm
Well,
just saying,
so
like,
we-
if
well,
I, if
we
I
have
lead
these-
a GoFundMe for a satellite, dude, they're gonna cook me, bro.
I'm trying to put this together. So we have these observable effects that are proportionally tied to the velocity of the clock, right?
Yes, sir.
So if we
Yeah.
assume that Earth is the absolute stationary reference frame, can't we build some sort of accelerometer off of that? Is that what you guys are talking about?
Well,
We're just gonna get the raw data. We're not gonna. We're just gonna
Yeah.
try to get the raw data, encrypt it, and store it cold, and somehow retrieve it. Well, we'd want to send it live, and try to store it cold, right?
Well, Ron Hatch, he was talking about, so they send up the satellites, and locally on the local computer, it's accumulating all the data locally, and then it can send off in batches. Like, okay, this is the
Yeah,
accumulated
but Ron
data
Hatch was
for-
given access to the raw data, right? Like he was literally brought in to fix the problems, right? Like that's what we're trying to figure out. Is it technically illegal for us to do that?
Yeah.
Send
Yeah,
up
you're
a
not
radio
gonna.
clock on a rocket.
So,
But dude, I'll go to jail. I'll go to jail if I get all the permits, but I just put an
No,
accelerometer
I'm
on
pretty
there.
sure
Like,
Dell,
okay.
Dell said you
There's
could
plenty
just
of-
tape your own computer onto the bottom of the CubeSat, and then they'll set it up for you.
there's plenty of publicly accessible satellites that you can tap into. It's just do they provide accelerometer data? And obviously we're not going to trust a NASA satellite because they would just send a zero all the time. The accelerometer would be reading zero all the time, of course, if it comes from NASA.
And we already know that's being corrected.
Like the whole point is to corroborate it. That's like, it's for science.
But do we all agree that there should be no way that if it's circling above our heads, it should produce a zero, right?
I don't know. I really don't know.
Like, I don't know what goes on up there. We have to figure it out.
That does make sense in theory, but I really don't know what's going on up there. Those things move very fast.
Because it'd be the same as a tether ball circling a
Yeah, it's
tether
changing
ball pole.
direction. It should definitely read acceleration.
Maybe gravity doesn't attenuate according to r squared based on the ball number. Maybe it's a different coefficient.
Well, yeah, maybe you get high
If
enough
you
too. You're like
have-
not really messing with the electrical field all that much, right?
I mean, there's a whole lot of
But the
variables that
inertial
change.
response, accelerometers use inertia.
You have a preponderance, like you have so many variables that change at that altitude. So many. Temperature, pressure, ether, density of everything. Like probably density of the whatever's there itself probably changes. I mean, you can't make too many assumptions about it, but I do agree there should in theory be some kind of noticeable.
But here's the thing, right?
correlation.
When you start thinking about think about like a plane and its airspeed, and then its airspeed's in relation to the static pressure around the plane. Now imagine like ocean rotating around you and then throwing a CubeSat in it, and it just like surfs around. Right, you're gonna have to distinguish between like the static pressure outside the sat.
So you're saying if it was being carried in the ocean, would it experience an inertial response?
Well, it would experience it for sure, right? But would it? Yeah, would it? Well, I mean, would it experience it itself as opposed to externally? Because if you think about a plane, right? Like the plane doesn't tell you its airspeed.
Well, inertia is universal. It's like inertia, inertia is a super interesting thing to research. Like what's even like the fundamental grounding of inertia in the first place? Why does it exist? It all comes from the fact that anytime something moves, it's moving through space that is filled with, ether, and it has to push ether out of the way, and then the ether pushes back on it, and there's your inertia, right? There's a reaction, there's an action reaction happening.
Yeah.
But like that should be universally present. And I think that the reason that accelerometers don't register in free fall is because they're tuned to gravity at rest, right? Like they're already experiencing 9.81 meters per second downward at rest, and so they zero it out at that. So that's considered their 0 point of whatever experiences at rest. So once it goes into free fall, it minuses that out in the other way because it's no longer resisting it. So that's treated as a zero. That's the reason that they read zero.
It was a bit of a tertiary point, but you said that an airplane doesn't measure its own airspeed. That's actually not true. They use a pair of mechanisms. One is the pitot tube that goes into the barometer, which is the altimeter. The other one is the flow-through gauge, which is out on the wing. And what is left of the atmosphere at the altitude you're at is indeed blowing through that apparatus at a given rate that causes the wheel to spin so fast. And what the flight display does is it makes a calculation using altitude, as in the altitude figure based on your density, and the flow rate to tell you how fast it's actually going.
Okay, that's cool. I didn't know that.
I do
But if you're in a
remember
wind
something.
stream, you would still be It would be relative to that wind stream still, or a jet
I
stream.
just something just jogged my memory about the accelerometer thing, though, which might be a problem in trying to measure. I remember there was a university that sent up a rocket, and they were shooting this rocket to around 315 to 330,000 feet. Anyways, I remember that when they reached like 150 or 60,000 feet, they got locked out of GPS because they had a civilian module and it gets locked out. And then I think once they hit around 250,000 feet, their accelerometer stopped reading.
Yeah, see, that's crazy. I remember you saying that.
Yeah, after
because like
yeah.
because the jet stream is like a good analogy. It's not perfect, but it's pretty similar, right? Like the jet stream is moving a circle. Like I don't know, right? Because then you get into all kinds of things. Like if you just look at the ISS, like how is it going that fast? And it's clearly not really experienced any serious resistance.
Yeah, can't be.
Yeah,
It,
so
it
it's
tear
like
apart.
super fluid or something, super fluid, or it's like actually just the gradient continues until some type of containment or whatever, right? Like it's clearly not going through air like that.
I mean, there's
So
no air up there.
yeah, but the question is there something else, right? Because
Yeah.
because if you extend that out, if you keep going, so you can kind of apply the same principle to the motion, the celestial motion.
Mm-hmm.
So Steel to Bike Tyson was streaming recently about how they're going to deorbit it soon. They're going to bring it on down. I hope that's free tacos for everybody in the States this time. That'll be just great to see.
I do know that the university had to model just with the kinematic equations, like project from 250K feet to the end. They had to just run the simulation based on, we're not thrusting anymore. This is how much carried velocity we have. We could just use the kinematic equations to tell, how high it goes.
Dude, that's exactly where we need to know what's going on, right? Like,
Because instruments didn't read anymore.
well, okay, that's weird. I mean, you think they're just being shut out of the data or like?
Well, I think because no, it was their own stuff. Because they're reading it in real time. They just antenna to their rocket, right? I mean, the rocket didn't go that high, right? They just shoot a rocket to. It's like 50 miles is 260,000 feet, so they went to like, I don't know, 60 or 70 miles, I want to say. But anyways, if the thing is going upwards and it's decelerating, right? It should still be experiencing changes in its accelerometer just the same as
Yeah.
it was when it was accelerating upwards and then its engines kicked off, but it still had carried velocity. Like until it reaches the peak and then falls back down, that should be the only time the accelerometers don't register because they're zeroed at little g. So it is super weird that the accelerometers like weren't able to register. We should probably look that up, like look into that. Dr. Mike, do you have any input on that?
I'm not sure I was following that. Could you ask that again?
Yeah, TLDR university sent up an amateur rocket to like 320 something thousand feet or so, and once they got above around 250,000 feet, their accelerometer stopped reading, it stopped registering. Like why?
I'm not sure why that would be.
Yeah.
Because accelerometers measure proper motion.
Right.
It basically, they're really what they're doing is they're sensing gravity.
Right. Acceleration and deceleration.
And how
Yeah.
so what they've got a little weight inside, and they're sensing how that moves relative to the case, which is all determined by how hard gravity is pulling on the weight inside. So I can't, other than something that's orbiting at that altitude, I can't conceive of a reason that an accelerometer would stop reading at altitude if it's not in orbit.
Right, and it
Well,
wasn't an
this
orbit, it's
is,
just up and down.
dude, think about this though. This would actually make a lot of sense though in an electrical field. Like they're not using optical accelerometers, right? They're obviously using like electrostatic or piezoelectric, piezoresistive, capacitive, whatever, right?
MEMS.
They're not using optic. Yeah, and there are different variations of it, but they're all the same base principle, right? So like, okay, so if there's some change in electrical field at some certain altitude, right? Like that would, if you're hijacking that effect and calling it gravity, if there's a change in electric field at a certain altitude, well, that would be
The
like a
boundary
huge
layer.
variable. It wouldn't care. It wouldn't matter if you're shooting a rocket up or shooting a satellite in circles. It wouldn't matter, right? Like
maybe maybe that's the thing that happens when you see the Chinese rocket, that one really big Chinese rocket, and the Elon Musk rocket, when they look like they punch a donut hole through like a fluid, like a translucent, transparent, like, you know what I'm talking about? They hit a certain
Yo,
altitude and it.
speaking of Chinese rockets, we can come back to that.
Sorry,
We're
bro.
still,
All right.
you're good. You're good. We're still about to wrap up our thing. Did anyone else have anything prepared to say or whatever? I know some people sent some stuff to Kat. And was there anyone else that had any questions or comments or things that they wanted to talk about?
Yeah, dude, I'm just
Wrap up.
thankful to be a part of this community. Really briefly, I joined up. This was 3 years. I didn't join up in August of 23. I think it was like November or December. But yeah, I saw a Witsit stream back when he was doing Schooling Globers, and then I joined EA, and he was giving a prezi in there, dude. And I like asked a few questions. I think I asked him about like, we were talking about light and the ether. And I was like, well, what is a mirror then? Like, how does a mirror reflect light? It was like a, I remember asking that question, and then ended up coming in here, and been a little cool little journey ever since, dude. I've like learned a ton. Like, just got spun up pretty quick and figured out physics makes a lot more sense with when it's mechanical. And dude, I hope and I pray that may the Lord like bless this server and all the people in it to know his truth and to know him and to be saved through faith in Jesus, and also to find out the truth of this realm which he created, because the creation testifies of the glory of the creator. So pray that he gives us knowledge, you know, like supernaturally through his Holy Spirit will like move things and cause things to occur, so that like within our minds we become enlightened to the truth of the realm that we live in. And it can be used as an instrument to teach people the truth and wake them up. So thanks for doing this, Alan, and Toby. You guys started this. Thanks for doing your prezzies with it, and starting the stuff that you did with Schooling Globers, and it helped me out a lot. And I'm sure that and Shane and everybody else that joined, I'm sure that everyone in here has been helped a lot too. But it's unknown. It's like untellable how many people that you'll never hear from, that will never reach out or ever try to talk to you, that are out there, in the world, that saw your stuff through the internet and have been touched by it too. So it's actually there's a lot more people that you don't know that you've helped than that you do know. Just keep that in mind, bro, and let it be a motivating force to carry you forward. I got some deja vu right now, so I'm gonna hop off the mic.
Well said. Thank you.
And
Bro.
I'd like to chime in and say you're able to even help doctors of computer science. I've learned a lot in the time I've been here, and I'm still learning. And this group reminds me of the study groups we had like half a century ago when I was just starting out in college. And we'd get together and we'd talk about crazy ideas. We all believed in relativity at the time. And that just spawned some crazy talk. And this is that kind of group where you can talk about crazy things, you can have wrong opinions, and not be subject to scorn. Um, we just help one another talk through the issues. And Whitsit, I think, brought up an excellent point about that I hadn't considered when I was talking about accelerometers, because I've got an old-fashioned mind that was thinking about the old-fashioned type that are still based on weights, but the modern ones based on electrostatics. There's a lot of things that can influence them at altitude and throw them way off. It's hard to keep up with science because it's a moving target, and like Run Boston Bear pointed out, we have to sort through a lot of fallacies. And this is a really, really excellent group for doing that. So thank you for starting this group 3 years ago, and I'm glad I've been with you just over 2 years now. And I think we have a lot of exciting things to discover in the future.
Well said, and thanks for your influence on our community too. The null hypothesis, the celestial theodolite, breaking down Kepler's law in terms of like vortex mechanics. been an awesome journey, and thank you for going through it with us all. And thanks for being patient too, especially when it came to some of the math concepts when you were doing, when you were trying to walk us through cell theo.
I'm not sure I deserve the credit for being patient, because one of the things I learned is, although I can conceive of complicated things, is often difficult to translate that into English that somebody else can understand. So thank you for being patient with me as I tried to describe things to you. Like and thanks to people like Piezo who like question some things. Jesse never liked the J factor being honored in named in his honor, but that's what helped us discover the real problem that the J factor was correcting for, is the fact that they were failing the central angle theorem. And eventually we
Yeah.
discovered that as a team.
Yep. Yeah, that was awesome,
It's
dude.
just amazing what collectively we can do.
It's like, hey, what's this number here that corrects both the? Oh, the sum of it is the amount that they said it should be curvature. Oops.
Yeah, I love the way you state it. They're off by exactly what they claim is the curvature of the Earth, because they didn't realize there's a central angle theorem that applies to them.
Yeah, that was awesome, man. And then finally, making the connection to what it was fantastic. It all came together finally.
So I heard Dr. Mike is writing Alan into his will so that like 40 years from now, when Alan's retired, he's gonna like get all the secrets of Dr. Mike and be able to share it with us.
Oh darn! I already promised those to my older daughter. I only have 2 daughters.
You just make a Xerox copy. Don't worry about it.
Yeah, you gotta make a kill
What
switch.
that can do.
We're giving toast. I'll give my toast.
Yeah. You're good. Go ahead.
Because I'm trying to think when this place became a thing. I remember that, I remember loving this place because it was like a safe haven. And Alan would ban everybody that came in here that was like trolling. So I didn't even want to promote it, I wanted to be like, go listen to them, but don't go there. But yeah, man, it's cool, dude, because then we popped out a couple babies back to back, and I was just running around all the time, and then you guys were always putting in work, and then I could tap in, and then you guys would just give me the rundown. It was super clutch, and then anytime I had a debate that I procrastinated on, which was every debate or presentation, I could come in here and you guys would help me out or refresh me or whatever. And then when I stepped away, this last over a year or whatever, I would occasionally come tap back in, and I'm like, oh, we're good. They're still carrying the torch, so we're good, So, yeah, Ether Cause is still at the top of the top, kind of cutting edge for me. Anytime anyone asks me, so I think you guys are a bunch of legends. I think it's also a testament to how much work they had to put in to refine the model that they've kind of fed us, and just think about the amount of hours that Alan and Shane and Piezo and Toby and all the people in this room and all the nights that you've gone through all the literature and think about the amount of work it took and the amount of hours. I mean, it's of course they've gotten away with a lot of these little tricks, right? And most people don't even know that they're tricks. So, I mean, I don't want to sound hyperbolic, but I actually do think it's kind of historic, because I really don't think that you're going to see anything like that anywhere else that's ever happened, right? Because it's just so much to it, relativity alone, and then how that's applied to everything, and the corrections within for practical purposes and pragmatic purposes is insane. And every time that you guys would start digging into something, it would take maybe a couple hours, maybe a couple days, whatever, maybe a couple weeks, and then we would find the big trick every single time without fail, every single time when we get to the bottom of something, right? And it takes people that are diligently going to look into it with good faith, admit when they're wrong, try to have it intellectually honest discussion. Yeah, I think you guys are like the cutting edge of that. So props to you guys and much love. I think you guys have. I know you've helped me out a ton, and I get lots of messages about how much you guys have woken people up, and I send people to you all the time. So yeah, man, much love. Place is the biz.
Thank you, sir.
Thanks,
Thanks, man.
awesome. I
Yeah,
I
thanks,
would
bro.
like to just say, like, yeah, I started this as a 24/7 server that was going to be a YouTube live channel type of thing, and then I realized after the first like 24 hours that I hated that idea. And we started doing presentations, and Alan showed up, and Alan started really going hard and doing some awesome presentations. Um, but my idea here was, I mean, like my whole goal with all this is like, like the models are cool. Like the work Alan and Shane and now I see Witsit's doing some stuff now too. Like I love us having like theoretical models that we can show. But I would quickly just also say like, like we're not claiming this is the truth. Like it's just if you really need us to show other theoretical possibilities, like here are ways that it could happen. And I I we don't have to explain things. And I guess my larger point is you should never ever let anyone make you feel like your cosmology is a conspiracy. My cosmology is not a conspiracy theory. You don't have to explain anything to anybody. You don't have to explain NASA. You don't owe anyone an explanation. This is a personal way that you find your grounding in your world and your reality. You just feel the still ground beneath your feet and be done with it. You don't have to internalize cognitive dissonance. You don't have to internalize this idea that if you go faster than this quote unquote speed of light, you're going to age faster. There's none of this weird craziness where light behaves differently depending on if you're looking at it or not. There's not like a weird mystery darkness behind all of this. Just apply some logic to your existence. You likely exist within something, not detached from everything else. And it's really important. It's a different mindset. If you're the type of person that thinks like that, which not everyone is, then it's. I think it's something at least worth considering. It's good for you mentally. But yeah.
Word.
Well said.
And Alan, yeah, thanks for keeping it going, man. Holy cow. You just keep on working and working. And I think we all very much respect you, like all the things you've done for I don't know, picking up the torch for me, because I, started the server, but of course I've been absent quite a bit for the last year or so. And, people get busy, things happen. Shane is not always here to manage things either. And so you took over the Discord server, but more importantly, you kept the research going and you keep the community alive. And yeah, so thanks for that.
Well, thank you. You started it all, and made it possible. Because I was not gonna set up a Discord server or do anything, but you did it. You got it all going, and I was like, well, it'd be a shame to let it go to waste. So it's been fun.
Dude, what's pretty crazy is Bob would have loved this place, man.
Oh, I
Bob would
know.
have
I would have
freaking.
loved to
Oh
talk to
man,
him.
dude, he would have been right there with you every new discovery, man. So, it's really kind of poetic that you guys carry Glowbusters, right? Because once Bob left the picture, right, it was just like a huge void of a lot of this, right, that just didn't exist anymore.
Yeah.
So yeah, it's clutch.
Yeah, dude, we've honestly gotten to I feel like, well, maybe I'll speak for myself. I won't speak for anybody else, right? But like, I feel like we've gotten to the point now where we've figured out so much of like the mainstream paradigm that we've almost got, prezzies and analyses of every major experiment family down, to where like I personally have had to resort to looking into just like regular old cutting edge electrodynamics and like satellite stuff in order to like not get bored, because it's like they don't have any mutually exclusive stuff left to go through to pick apart anymore. It's like we've pretty much documented all of it, as well as a bunch of, you know, examples of where their model breaks. And it's like there's only so many experiments that have been conducted, right? And there's only so many case examples or families of case examples to display. It's like I'm actually getting to the point now where I'm like, dude, like I want some new stuff. Like where's the 2025, 2026 like cutting edge physics experiments that, and honestly, the stuff that I found, not to I'll try to keep it short, but it's like there's a lot of stuff with superfluid vacuum theory and things adjacent to it that have been going on the last few years, and the mainstream is like slowly adopting a like medium based view of the universe. It's actually pretty interesting, but the old school academicians who still run things are like not about that. So it's really interesting to see like the older school people just stick to their guns on this like purely empty space-time relativistic stuff, while all these emergent researchers are writing papers. And I mean, there's like a whole huge Wikipedia page on superfluid vacuum theory, for example, and doing all this different analog gravity, acoustic gravity analogs research that is like clearly only possible if there's a medium. So I'm just wondering
No,
if the pendulum's
well,
going to
that's
swing
my
back.
question. Why are they so scared to admit there's a medium, right? They do everything but accept that there's a medium, right? They
Because all
relabel it, call it
motion is,
fields.
yeah, because all motion would immediately become relative to it, and you'd have to answer why Earth doesn't have a velocity. It's the whole. It's
Yeah,
the whole.
they
It's the whole.
need
It's
the
the whole.
isotropy of light. That's why.
Yeah, yeah. It's the whole reason.
It's literally just
Immediately makes
because
the
of
Earth stationary.
yeah, yeah.
But they have to
Even
inevitably get there, right? I mean, it's the literal only place to go.
yeah, even vacuum fluctuations, all motion should be relative to those. That's why they uh, don't even consider those as physical. They try to explain it through abstractions of like virtual particles coming in and out of existence and stuff. Because as soon as it's physical, they immediately all motion's relative to it.
But it's not physical either. It's which is the hilarious and retarded part. It's like
Right, right. You're looking at a physical interaction, energy fluctuation occur, and you're like, nothing here but virtual photons, my boys. It's like, all right, dude.
I got some
All
math
right.
in a field if you want that or whatever.
Field is
Yeah, well, dude, it's getting pretty late here. I know Shane's got a couple of things to read in from some people who couldn't be here. So yeah, let's get those, and then
Let me
let's
say
wrap
something
it
real
up for
quick
the night.
before you.
Yeah, go ahead, Dave.
Yeah, definitely. Thanks so much. Happy third
Thanks.
anniversary, and thanks for yeah, all the work you guys have done. I think I was lucky enough to be at the inception when Toby decided to start this, and I think I was talking to you and Toby, and he was like, "Yeah, that ether is what makes it all make sense," and I'm, planning on starting this server that just dedicated to that because that's what people are missing more than anything. And shout out to Witsit for I think being kind of the instigator of what kind of brought us all together, rallying around his dealing with people that were trying to like take the ether out of the conversation as far as the flat Earth conversation goes, which is ridiculous, and it was just obvious that it was like an intentional negation of whatever the ether is, and the fact that it has so much context for the conversation, regardless of what you think about the ether, it was just like, man, what the hell is going on here? And it's been so important. It's like the next level of what people should be paying attention to um, for the academic part of it. And I've seen a lot of stages of quote unquote flat Earth, and you guys have just come in and just pushed it to another level like I've never seen before. And it's been amazing, you know, with Shane and to begin with you guys, just like all your proofs are ours now. What was it like? Belong to us, and it was just like one after the other. You know, it was just like so many different stages of this. You know, this whole thing where, you know, just owning it, and then they've always done that with everything. You know, whether it be one test or another, that like you know the Ares failure, they try to own that. And, Michelson Morley, you know, disproved the ether and these things that were just like the total opposite of what the claim was, and rectifying that is so satisfying, because there's really nothing they can say. You know, when you actually go and look at the work, like look under the hood, like Alan used to say. He started reading these ether books and stuff on his own, and that was like the spark of it for I think Toby, and then we started rallying around that, and it's just been fun. It's just been like so successful in such a modest way, because you know you're not going to get any of the glory, because it's so damning to the paradigm, and that's when you know it's worth it, because there's no expectations of anything as far as you know what kind of credit you're going to get from the mainstream, and that's when you know you're doing the right thing, I think. So it's too bad that's the case, but that is the case. And yeah, I mean, there's so many stories I could tell, but I'll wrap it up. I'll just say, you know, I'm glad to be a part of it, and you guys have just been amazing to witness the forces come together and make this happen. It's only going to get bigger from here, and it's just the people that are realizing the importance of the ether, or you know, looking under the hood, that are going to appreciate it, and I sure do. So thank you, and happy 3rd anniversary.
Nice. Cheers, Dave.
Thank you, sir.
Absolutely.
Alan, you mind if I give you flowers? It'll be like 30 seconds. I'll be really quick.
All right, but no longer than 30 seconds on the flat. Nah, go ahead, bro.
And go.
Dude, real quick before you go though, awesome post on Twitter, by the way, about the Aries and Clinker fuse. That was fantastic.
Hey, no problem, man. Thanks. I really appreciate it coming from you guys. Yeah, man. You know, recently a good friend Indio passed, and I was a little bit bummed about that, because he was one of those guys that, you know, it's quality over quantity, even though he had a 24/7 server. And you guys share that a lot. You know, there's key players in this movement of truth, and it's important to be thorough. And that's one thing he had and you guys have. One of the earliest memories I've had of Ether Cosm saying, what are you guys are really about, was about Toby. We'd had a conversation, one of the, I believe it was one of the Flat Earth Friday spaces. We went on a 20-minute rant on epic proportions, and I fact checked as he was going. I'm like, man, this guy's spot on. 20 minutes committed to memory, and it's not just about memorizing repeat. He understood it, right? It's not just knowing the information; it's understanding it, taking it apart, coming at it in different angles. And Toby's one of the introductions I've seen to your crew, and it's been nothing but great things ever since. We hear a lot about the map isn't the territory, where anti-Red's rhetoric, math is reality, but it is important to dive into the papers, and that's one thing I got from you guys is understanding their math, right? Even though we know math isn't reality, we understand diving back and pulling back the layers. A lot of the math is on our side. There's a lot of fallacies embedded in math, and that's something I learned thanks to you guys. So keep doing up the good work. I know that was more than 30 seconds, but I'm excited to see what's ahead.
Dude, a mathematical fallacy. It's a new type of fallaciousness. Yes, but also
Dude, I gotta say one more. I gotta say one more thing real fast, dude. New perspective just reminded me. I totally forgot about that. That was the. So I was getting like crucified for the ether, and then you guys like kind of rallied around, and then Toby went and made this, and you guys just like took it like 1000x, and there was like this conglomerate of people that were like, no, Fe is this, and it was like the same 4 like reductionist arguments, you know, and look at everything now, right? Like look at, if you were to point to the cutting edge of Fe, it's clearly like right here, which is just a testament to like always pursuing the truth and where it actually leads you, not being afraid of any specific topics. It's not about like playing little games or tricks or having gotchas or like little debate tactics or whatever, right? Like if you just if you follow the truth, this is where it ends up. And like that foundation of kind of accepting this like metaphysical primary background, right, has like spearheaded all of this that we've discovered. So it's pretty epic. I mean, haha, I guess, because there's really no dispute at this point, kind of like who's pushing the conversation forward.
Yeah, man, your Ether presentation put that seed in my head, which even started my transition to understanding the opposition to atomism and getting out of materialism and fitting in the whole understanding of the scientific consensus. And I think that probably infected other people the same way. So really, this whole thing is indirectly because of that one presentation you did that one time.
I was going to redo for 4 years or whatever.
That you've never redone. Yeah, we just accept it.
Yeah, I'll redo it tomorrow, dude. Stay tuned.
So yeah, cheers to everyone for fostering a community of, let's say, co-inspired education and growth, right? Positive reinforcement to inspire everyone to do better. And I think that's, cheers to everyone for keeping that going.
Thinking back, it was also almost exactly 3 years ago. I remember being online at 2 a.m. and I hardly knew Alan still. And I see Space Audits is streaming. I'm like, what's this guy doing streaming at 2 a.m.? And I click in and he's just live reading Adatovsky's Ether Dynamics. And I was like, oh, this guy's awesome. I'm definitely going to be friends with this dude. And yeah, look at where we are 3 years later.
Hilarious.
He has that effect, doesn't he? I remember, I don't know, I joined Ether Cause in November 23. So it was either October or November of 23. Somebody told me, hey, we're going to have a speaker on Flat Earth Friday. So this Friday, his name's Alan. And he's going to come in and talk about the ether. And I was like, what? And I was of a mind that, there was no ether. There's just nothing to it. And so I remember somebody saying, well, we just hear him out. I said, well, I may have a little pushback on this, just be nice. Well, I'll be nice, but I'm going to push back. And I remember going in with that mindset, and it was like 30 minutes later, I was like, who the fuck is this guy? I got to hear some more of this stuff. I couldn't talk to him fast enough. And I come here to Discord and I find Toby. And I'm like, damn, there's two of these guys. They're good. And then here comes Shane. It's Stone. And there's just a great freaking group of people in here. And I was like, who the hell knew where? And I didn't realize you guys were just 3 years old. Because you're saying August of 23. I joined in November of 23.
Yeah, I just looked it up. I said I joined June 21st, 2023. I'm assuming that was like right at the beginning or a couple days.
That was exactly Shane for me, by the way, Ken. That was when I joined Cosmology Tartaria. And it was like I joined because of Witsit's debate or something like that. I can't remember how I ended up in there exactly.
From Rumble, or something.
I was
some
like
offshoot.
blown away by Witsit's. Oh yeah, because you had posted Witsit's debate. That's what it was, and so I ended up in Cosmology Terraria. And then as I was like debating with people and chatting with people in there, I kept hearing Shane talking. I was like, oh, there's two of these people, like two people that can apply logic to this and like have open eyes.
That's what I thought when I met Shane. Dude, this dude just like started hitting me with all kinds of stuff. I'm like, what? Slow down.
Yeah, that was always like I remember just hearing the dumbest things always being said, and I would be like getting kind of perplexed, like, oh, are these people right? And then Shane was just like, I don't know. It was when I was really like starting to question things as far as you know, the relativistic universe, and the old arguments would start to come, and yeah, it's just I don't really buy any of the NASA stuff anymore. So
Yeah, didn't Ether bring you in? Like you came in the gateway of Ether.
that was way bigger deal to me, yeah. And it
Yeah.
made it all make sense, right? Because that's like to me, flat globe, you know, like not I didn't see the significance of it too much, but then it's like, oh, like all this crazy stuff I learned in high school about like relativity and like time bending and like these things that like literally just made existence feel dark to me. Like this is like a weird bent like existence that doesn't follow its own logic. And so, yeah, like it's very it's like you're literally putting cognitive dissonance in your head. So I think it's just bad for you. And yeah, and so once I could realize that all of it all fit together, and you could explain away, you could take that stupid relativity crap out and not have to embrace a relativistic reality. Once you could pull that out, it's like I don't care about any of flat globe whatever. Like it's like just tell me I can actually measure something in reality and it's actually measurable and it's not, you know, relativistically based on some other observer point. Like that's insanity. That's literally like it's literally just forcing yourself to detach from reality.
Gaslighting your own soul, which Toby is against. We all know.
Yes. Yes. Thank you. Thank you, Shane. Is literally
there's still
gaslighting your own
one.
soul.
There's still only one burning question that hasn't been answered yet. And I want an answer to. So has Shane slowed down so that we can understand him, or is mine just
No, I was
Hell no.
No, I was just thinking that. I was like, that's one thing that he's done that I've never learned that I should learn. That he slowed down since then, and I definitely have not. I made
Pros and
zero
cons.
effort to
Pros,
do that.
pros and
Yeah.
cons. Yeah, pros and cons.
Hey,
think you
I
should
have
just
a
keep
quick.
going.
Sorry.
Sorry.
No, go ahead,
I
Lily.
I have a quick Alan story. The way I discovered Alan was you remember the old Flat Earth Fridays, you know, with the old team. My God, everyone's name is just suddenly left my head. But
Level
anyway,
heads.
yeah. Anyways, the old Flat Earth Fridays, right? And I thought that it was just for people that were new to Flat Earth that were getting introduced. And I was like, hey, it was too boring because I was already a flat earther by then, right? And then one day I just like out of curiosity to see what was going on, I went on there and Alan was talking. And I was like, wow, here's a guy that really knows what he's talking about, and he's not just giving us all the kindergarten, you know, flat earth 101. And he's like, he knows what he's talking about. And that's when I really like tuned into Alan G. And then I got introduced to the whole team. So it was Alan G that brought me to Ether Cosmology. Thank you, Alan G.
Welcome, Lily G.
Nice. Yeah, I got a couple notes here. Let me go
Yep.
through. There's only like two from our
Nice.
boy Dom. No Globe Dom.
Dude,
I think,
shout out to Dom.
We really got to give him a different shout out for his
Hey,
whole
how's
community.
Domi doing?
Dude, absolutely crushing Stone. He's popping off. So they were running the Ether Cosmology CZSK variant on YouTube. They got banned because he started covering the Epstein stuff and, you know, more of the political conspiratorial stuff. But it was pulling in and it was getting a lot of traction. So they iced his channel. He went over to Kick and now he's popping off and doing great. He's disseminating a lot of truth and spreading you know, just like all the questioning all these, you know, political narratives and stuff. He's doing great.
One door closing and another opening. Sounds good.
Yes, sir.
Yeah, I think he's taking over the country. I think he's like debating astronauts. He's doing like debating scientists. I'm only half kidding. He's like, I've watched his channel like translated and stuff. When he speaks in his native tongue, he
Your mic cut out. My mic cut out.
Me.
Oh,
what happened?
Oh,
Sorry.
Discord died.
You're back.
Discord's bugging.
Oh wow, it's
Yeah.
not just me. Good.
Yeah, I think it was
Yeah.
the server.
Yep.
You were talking about dummy.
Yeah, the
Right.
feds are in here, boys. Be careful.
So his message says, "Please let everyone know from me that Aether Cosmology Check only exists and works because of you guys. What you created gave us the foundation and inspiration to build something incredible here in Czechia and Slovakia. And today I genuinely believe we have the biggest and best community on the Czech and Slovak alternative scene. So a massive thank you from me and the whole Aether Cosmology Check community. Happy 3-year anniversary, Aether Cosmology, and here's to many more." And he gave Alan beer, of course.
Nice, dude.
Here.
But yeah, his whole community is amazing. I think whenever we go down there and participate, he has a whole series of active participation. People always asking genuine questions. He has his own detractors who we ran through a couple times, which I think are genuinely entertaining series of lads. But yeah, cheers to Dom. He's definitely one of the good ones. A legend. We got another statement from our boy Carice. Says 3 years gone and many more to come. I'm grateful in several ways to this fine community, in particular the sincerity of the conversations that go on here, in large part to Alan's vigilance, the intricacy of the information presented due to Shane's designs, and the quiet framework begun and maintained by Toby. Thank you guys for allowing me to serve this community, and happy anniversary, Aether Cause.
Word.
Dude, shout out to Carice.
Hey, don't forget the multimedia mogul Sam.
True.
Sam
that.
here?
Yeah, he's here. He's
He
probably
checked in.
he's
He
probably
checked
falling
in 2
asleep.
hours ago, but I don't think he's still awake yet.
He's probably recording all of this stuff and processing it all in parallel on 4 different machines right now, so he can get it all uploaded to YouTube like tomorrow.
Rate it up. Gotta rate it up.
Is Gally here? No, Gally's not here. All right, so I'll read Gally's too then. Says 3 years is a long time. I've been here for 2 and change. When I first joined EtherCause 2 years ago, I was a mere debate bro who loved the art of debate and found one of the most hated and fun topics to debate was this domain of study of our cosmos. Also defined as, says cosmos, also defined as an orderly arrangement, a decoration. Or number 2, the world including its inhabitants, or simply put, the entirety. Through vigorous, persistent, agonizing questions and pockets lined up with citrus-flavored lint, I successfully annoyed Alan, Shane, and Toby with questions and inquiries about stuff they had already went through dozens of times, and they answered with peace, grace, and persistence and kindness. Truly, I'm thankful to be part of such a kind, fun, and most of all, fruitful group. A space became much more for me as I developed with my spiritual beliefs and a little space Alan allocated me and my little theological group, the Morning Lobby. I'm extremely thankful for the connections I've made along the way and the extreme amount of resilience and hard work those fine lads and ladettes have contributed. Yes, to happily call it my home. Cheers, Gally.
Cheers, lad.
Yo, yeah, cheers, Gally.
Oh yeah, Gally's a homeboy.
Here.
I'll say something too if I could. You know, it's been a heck of a
means.
ride.
Yeah.
Been through a lot of ups and downs since I've been in here, and it's actually been like a huge help. So I always look forward to the next video and what's going on. So it's I really appreciate the consistency and admire the consistency from everybody in here. There's not much else I can say that already hasn't been said. I really do believe this is also the cutting edge of not only FE, but civilian critical thought. And I value it very much, and I'm appreciative of everybody in this room. So yeah, just thanks for everything, and just keep on trucking.
Thank you, sir.
Thanks.
Awesome, man.
I will say that it's probably not a lie that we might have one of the heaviest concentrations of weaponized autism in the cosmology space on Earth.
I wouldn't challenge us to a bet or whatever, you know what I mean?
Challenging me to a weaponized autism bet, dude. I'll take it. All right, dude. We're gonna wrap up here. We've been live for almost 3 hours on this one. Did not see that one coming. But thank you guys all for the support. And like I said, it's been an honor and a pleasure serving with you guys and learning with you and all of that. It's been great. Look forward to continuing to do it. And yeah, we'll see you guys on Friday for the Twitter community space. And then we will be back on Tuesday for hopefully a little presentation on a little device called a gyro compass.
Cool.
Oh, dude, that's dropping. I'm looking forward to that one, dude.
Dude, I've been procrastinating and playing
this is
video
great.
games, but I'm definitely going to
Same.
finish it. All right, lads. See you guys.